So good morning, everyone. Let me get up here so I can actually fall down in the end. It's so small. I hope you all had a good night's sleep and made it here. Kind of like we're now a little bit not too much traffic. Well, welcome to the Masterclass. Today is about front-end performance optimization. And I will lead you through a lot of things, so get ready for a lot of input. It's going to be a lot of information, I think. Quite a big topic. So let's dive right in. So if you don't know yet, my name is Holger Bartel, and I'm a front-end developer and consultant, and I run an agency in Hong Kong, whereas I'm usually from Germany, like originally from Germany, and work in Hong Kong. I do a lot of basically front-end. I used to do full-stack stuff, but now mainly front-end development. And obviously, since the Masterclass is about performance, I specialize in web design and front-end performance optimization stuff. So I can geek out on that, and hopefully after this class you will do the same, because it's actually quite a cool topic. I was here the last 2 years, and if you have been here in 2014, you might remember I was speaking also about front-end and performance and faster sites. So the bottom line was okay, faster is better. So if you actually remember that, that was a fun talk as well. So to start off, I was thinking I want to kind of make it a little bit sort of interactive, because otherwise I'll be standing here for a very long time just talking. So it would be nice to actually also get some feedback for you, and to actually make you wake up and get some of your ideas on this. I want to know what you actually expect from this masterclass, because I know obviously what's going to be in, but it would be interesting to get some ideas of what do you expect and what do you think you'll take away, or what you would like to take away. So maybe, I don't know, I can just randomly pick someone, or maybe if someone wants to have a go at what kind of expectations or what you think you would like to have covered in there, please go ahead. There's a microphone in the back and there's a microphone in the front, and it would be great to get some input from you on that, so we actually kind of align a little bit on what's happening, because I don't actually know what you guys do and if you have worked with it before and so on. So anyone wants to have a go? Please.
The
mic is on.
Hello, Mr. Holger. So what I expect to learn today is about how using optimization tools, because I know how to do web development, but I don't know how to measure. How do I make my site faster, and how do I know if it's slow? Those are the tools that I wanted to learn about today.
Okay, great. That's good. We're aligned already, so that's good. Anyone else?
I'm interested in learning more about setting up basically workflows, and about testing, how to measure the speed of what happens after optimization.
Okay, great. Perfect. Anyone else? Or no? Everybody's still not really awake? One. One more? Okay. Nobody, I guess? Oh, okay.
Good morning. Since you're pro, I just want to know your best practices, your discipline in coding.
Okay, cool. All right, sounds good. We're on the same page already, so that's a good start. All right, so then I'll just quickly run through what we roughly cover, and it's going to look like something like this. So first of all, we have to kind of plan on how to create high-performing sites, optimization strategies, how to analyze for these things, because you actually need to find out, okay, where and what to optimize for. Then it's like the tools you need for that, image optimization, CSS, JS, and so on. And then for the second part, it goes a bit more into like the extreme performance optimization, whereas like extreme sounds like, well, it's basically the second step after you've done the basic, and if you then want to take it to the next level, that's what we'll cover after lunch. And that includes like rendering performance, optimizing the critical rendering path, and best practices for HTTP2 as well, because there's like some differences of like how we used to do things and how we will be doing things in the future. And then in the end, there's also like lots of tools and resources that you can read up on, look up, and so on. Because it is such a huge topic, I had to cut down on a few things, and some other things are like a bit more comprehensive. I'm happy to take questions at any time. You can also, if you decide tomorrow or whatever, like, oh, I have a question in regards to X, Y, Z, feel free to tweet me or to email me or anything. Totally fine. I'm happy to answer any questions you might have as far as I can answer it. And as I said, like some topics I had to cut down a bit. If we have like some time left in the end, I'm happy to dive back into some of those, or we do like quick Q&A or something. It would be good if we leave without any questions, even though like I think there's going to be many more questions after this. So bottom line, getting your websites from like turtle speed to rocket speed, that's the overall theme, and I think we're going to make that. That's going to be fun. So for the schedule today, we're starting obviously now. At 12 we're going to have a little lunch break, then we're going to resume. There's going to be another short break at 2:30, and then we'll end at 4. Because I haven't really like, I mean it depends on like how we go, maybe it's going to be a few minutes earlier or later. I hope that will be okay. And as I said, like if you have any questions even in between, feel free to ask them. Maybe not too many, because otherwise we'll run way over time, but should be okay. So since I don't know any of you, and I have no idea, I mean, besides like your expectations for now, it would be nice to get like a little bit of a better idea of like, have you worked with performance before? What's your daily job? Does that include performance stuff? Have you worked with tooling? And do you use frameworks or so? So, I don't know. Anyone wants to give me some feedback on that? And it would be good to have an idea on like kind of where you're at in the bigger picture. So maybe we'll start with the first one. So who has, maybe we do like just a show of hands. So like who has worked or like touched performance optimization before? Okay, that's a few more. Okay, cool, that's good. And in like daily work life, I don't know, I mean like sometimes it's very hard to push through for like performance optimization, but who of you like has to do with that like on a daily basis, or like whose work requires it? Okay? So that's a few less than actually who have worked with it before. And what about tooling? Like grunt, gulp, npm, whatever, all the crazy stuff. Okay, also a few. Good. And how many of you work with like frameworks, like Bootstrap, Foundation, you name it? Okay, that's quite a few actually. Okay, cool. You'll have a good takeaway on that. Alright, one thing up front, everything I'm going to talk about, there's like so many nuances to things, so it's very clear, not everything like works the same for everyone, so your mileage may vary. And as I said, like if you have questions, feel free to ask. I've come across like a few cases where I'm like, okay, this should actually be much faster than this solution, and then it really depends on like how you use it, where you use it, what the project is you're like, or what you're trying to achieve. It's sometimes a bit weird, and I really don't understand some of the things because there's like absolutely no logic in it, but the numbers speak for themselves. Like if you measure stuff, sometimes you say, okay, I don't know why that is, but so that's why I'm like putting that disclaimer here. I think it's always important to keep that in mind. All right. So far, any questions? No questions. Alright, good. I like that. Alright, so let's dive in. We're talking about web performance, so first of all, why do we actually need to speak about performance? Why is it important? Anyone else have a go at that one? Come on.
They have to stand up.
You can sit down if you want. If everybody can hear you, that's totally fine.
Because good performance is good UX. Basically, that's it.
Okay, so good performance is good UX. I totally agree with that. That's very cool. Good one.
Because these days, people want things fast. Like, they want fast food, they want faster things, they want almost everything. The web is not an exception.
Okay. So people want everything fast, and the web is not an exception. So that's actually a good one because that's like goes even further. Yeah, very good. Cool. Okay. One more.
It reduces maintenance cost.
Okay, it reduces maintenance cost. Yeah, I would also agree to that. I mean, also again, depending on your use case, but yeah, definitely a yes. All right, cool. So let's talk a bit about user expectations. Expectations, as you said, everybody wants everything fast, and like user expectations are very, very high. And this is like a kind of like a number that varies a bit. Like there's so many different stats on this, but I think this is like the average. Users expect sites to load within like 2 to 3 seconds because that's just like what users' perception is of fast. And then what we're trying to do today, and this is like what I said, like the second part is like we want to deliver something even faster than that. So that would be great. I think 2 seconds you're already pretty good. If we can get faster than that, that's even better. So there's a cool site which is called WPO Stats, like Performance Optimization Stats. Looks like this, and it has a lot of like real-world examples on there where like people have optimized their sites and they've seen like some improvement in whatever, like conversions, sign-up, downloads, whatever, you name it. So there's a lot of effort going in this right now, and it's become like a very big topic. And I don't know if you've seen it, but like Facebook actually started to launch like instant articles. And if you've ever used that, it's actually quite impressive because it's so fast. It would be nice if the whole web would be as fast, but that's only for Facebook. So this is like a quote from Facebook. I'm just going to read that out. This change improves the consumption experience in emerging markets because people will see fewer gray boxes, spinners, and incomplete stories. So that's why they basically launched those instant articles to avoid like any loading, and it's just like boom, right there. Like anyone has seen that before? I don't know if they launched it here or if that's like yeah. Okay, great. Like the first time I saw it, I was like, whoa, this is like insanely fast. So I'm not so sure about like data consumption, but that's like a bit of a different story because like they're preloading everything. Then there's another project from Google where first of all they said like okay, we're gonna put site speed into our ranking results like as a criteria, which is quite interesting. I don't think they have actually introduced that like slow label because we were talking about it. But basically, site speed is now one of the ranking factors. So that's like another important thing to keep in mind, because it's not only that like we want to satisfy our users. I mean that's mostly like the primary reason, I suppose. But it's also good for like search results. So that's a big one. Then also Google came out with the initiative of AMP, like accelerated mobile pages. Who has heard of that before? Okay, that's a few people. It's basically like a subset of HTML with like a few changes, and it's also lightning fast. If you go on this website, like the AMP project, it's insanely fast. So I'm not quite sure if I like it or if I don't like it because they're kind of pulling like the data into their like kind of well, I'll be careful with that, but kind of walled garden. I'm not so sure about that, but you can also reach that by optimization. Alright, back to user expectations. There's been like many surveys, but like basically it says 50% of people say they'll abandon a page if it takes longer than 4 seconds to load. So that's kind of like In correlation to what I said earlier, 2 to 3 seconds to load is expectation. If it takes 4 seconds or even more, then people will just leave. So that's like something you want to avoid. And there's a good table on user perception overview, which looks like this. So you can see 0 to like 100 milliseconds is like instant. It feels just like boom. Okay, that would be like Facebook instant articles. Then you have like 100 to 300 where like it's a small delay, that's okay. 300 to 1000 is like kind of the user thinks, okay, machine is working, but it's still like basically pretty fast. And then everything that's like more than a second, like people will actually realize, okay, this is like slow. And when like it takes too long, like people will like switch contacts, they will get like kind of distracted, do something else, or even like leave your site. So logical conclusion, this is like the same comment I made 2 years ago here, it's like faster is better. So this is like where we want to take it. Alright, so impact of performance. We talked about a few reasons why we want to optimize and why we want to make things faster, but there's actually much more to that, and this is quite an interesting part. It goes into like psychology and all these things, like how you actually perceive time. So everybody's seen like situations like this, or like this, where you just have to wait. This is also a funny one. Nobody really likes these situations. Then you come into like situations where it looks like this, and you're also kind of like, okay, well, whatever. It's like kind of. I personally hate loaders because it's like if you have to show me a loader for like something like this, it's just like, okay, that's kind of a thing. Anyways, we're talking about waiting, and so nobody likes to wait. We know that already, and I'm sure we all agree with that, especially looking at like the traffic in Manila. It's kind of, if you're not used to that, it's like, whoa, that's a lot. So the definition of waiting is actually the action of staying where one is or delaying action until a particular time or event. So delaying action is actually the key words here. Nobody likes to delay their actions. The other thing is like fast websites create happier users. So we kind of know that. And unhappy users, those we were talking about earlier, like who have like long delays in like page load or something, they actually do less or even leave your site. So that's where your problem starts. There's been like a survey in the UK, and that has like some interesting stats. So 71% of people surveyed feel regularly inconvenienced by slow websites. I think we can also all agree with that, it's just not as much fun. 50% believe websites have either not improved in speed or have become slower over the past several years. I think that's an interesting one because if you look at page rate over the last couple of years, it's just been going like up from like, I don't know, maybe like 600k, 800k in like 2000, not quite sure, 2006 or 8, until now it's like, I think average is like 1.6 megabytes, which is quite a lot, so can get quite slow. And also interesting is like 78% felt there was like some kind of like negative emotion when they like encountered slow websites. So that's like pretty full on stats, and like you get like the bigger picture of like why we should actually optimize, because it really like doesn't make people happy. We want happy users, obviously. 40% of users say the slow online transaction makes them unsure about the success of the transaction. This is also a really good one. So if it's too slow and you're unsure, you might also leave and go somewhere else where you have like faster results. 42% of men and 35% of women have decided not to use a company again as a result of experiencing a slow website. So that is obviously also very bad. So you see like there's like tons of stats out there, and these are all like from a source like I can, one is the sensory memory, short-term working memory. And the sensory memory is like basically like the memory that like processes like for a really short time. And there was an example there. So you have like a string with like a piece of coal, and they did like a test, and you swing it. And you know that from like, I don't know, I think it works with like cigarettes on beach or like anything that glows or fire or something. So You have to like swing it really fast until it makes like a continuous circle. And they found out that like the cycle completion was about like 100 milliseconds. So again, that like correlates to the numbers we've seen earlier. And the sensory memory is basically divided into vision, sound, and touch. So we're talking obviously about the vision part, but that's quite interesting because everybody knows that when you're doing kind of drawings in the dark or so, and some people take photos of it, that's exactly what they were talking about. Then there's another thing which is called flow, and flow is basically whatever you do it mostly in like a constant flow. Like it could be like you at home cooking, or I don't know, like all kinds of things basically. But like there's no big interruptions. You do one thing after the other, and you get like this constant flow of things where you don't get interrupted. It's not like you're cooking and then you like put everything aside, wait for 2 minutes until you actually get your spoon to like stir your pot or something. It's more like of a flow. And the problem with like flow is like once you're waiting and your actions get delayed, your flow breaks, and that's like when people like again don't feel like so good about the experience because it actually breaks the flow, and that is like what feels natural about it. So sometimes like people can create or come up with like coping strategies for like the broken flow basically when they have to wait, but it's just not really what we want them to do. Like we want to make sure like the flow is gonna actually flow nicely instead of like having interruptions. So faster pages correlate with like increased user engagement. That's like also kind of like the result of what we've been talking about so far. And slowness affects also like the perception of brand, and not only the site overall, but also like kind of can have a bad impact on like design, content, navigation, all these things. And I think also the brand part is an important one because you don't want to hurt your brand or like make it look like, okay, well this is like really not so great, even though it's like maybe it could be an awesome brand, but then you're just like its site takes forever to load, and people are like, oh well, it's really not that great. So again, happy users, that's what we want. So researchers have found out like we function at our happiest best, and that's like when we actually do the most and like accomplish the most. And we may learn to adopt to slower response times, but the adoption will always be kind of like weird. It's not, again, kind of correlates with the flow thing, is not the natural flow of how things should be going. Alright, so as I said, there's a book and it's actually free and it's awesome, and it has like a very, very long chapter on like that whole like psychology part, and it's really interesting. So I can only recommend to read up on that. It's fantastic. It's like once you get into that, you're just like, wow, this is really, really interesting. So alright, then now we're moving on. Any questions? All good? Everybody awake? Oh, question, yay.
What's the name of the book you're mentioning?
It's gonna come up later. It's all in the resources. So I don't want to mention it now because then otherwise you'll start reading it wrong. Alright, cool. So we have like a rough idea on why we're doing this.
Sorry, just a quick question about the Google ranking for site speed. Would you know if they have like a benchmark that if your site speed is this low, your ranking is gonna go down?
That would be great. But as with all the ranking factors, they don't disclose like what and where. I'm not quite sure how much it affects it. I know it goes into the rankings, but I mean it's like, I've once read there's like about 200 factors that go into that. So it's just a very small part, but it's a part. I don't know how what the percentages of like how much it goes in there, but I think it's mainly about like, if your site is really, really slow, then they won't like it. But I think everything like, I don't know, maybe everything between like 2 and 5 seconds is okay, and 10 is very bad. I'm not quite sure. Alright. So let's move into performance basics. So the first thing you need to do if you kind of want to optimize your site, either that can be like a new project or like an existing project. First of all, you want to plan for it. Planning for it requires you to know like two things, or maybe even more, but like the two more important things, the most important things. What do you actually want to achieve? Why do you want to achieve it? What's the end goal? And what's important for your project? So there can be various targets or like various ideas of why you want to do that. It could be like, okay, this project we need to accomplish like more downloads, or we want to have more sales conversion, or we want to have more signups, or anything like that. So, but have an idea on why you want to do it. It could also even be like, I do that sometimes. It could just be for the fun of it and like see how far you can take it. But usually in real life you have like actual goals, and you want to know why you're doing it. So one important thing to remember is like it's not like web performance optimization is not a one-off. It's more like an ongoing process. So once you started that, it's like you always want to make sure you actually come back to it and like well, first you analyze, then you optimize, and then you want to have a look at it like how it goes over time, and you have to constantly analyze it and be on top of it. I think that that's coming later. I have a good comment on that, and I'm sure like everybody can resonate with that because it applies in many ways, but that's a little later. So then you know why you're doing it, so you kind of like need a strategy. What do you want to optimize for? There's like many things you can optimize for. It can be network, server, front end. You can like optimize your rendering. You can go for load times. You can even like go for like smoother scrolling, smoother animation. I mean, there's like so many things you can do. But as a general rule, like the front end is the most important part. And I think the number is about like it takes like 75% of the optimization effort, or like not effort, but like impact. So, and here's like a little bit of why. So this is like part of the waterfall chart, and you can see like the network and server part is like fairly slow compared to like what happens on the front end. So it's basically just like DNS connecting, which is part of the server. You have your SSL handshakes and all that, and then everything after that is like front end. So we want to focus on the front end, and that's what we're also doing today. I mean, if you have other questions, I'm happy to answer those, but mainly focus on the front end because that's like where you have the most takeaways. So, okay, what's your best performance strategy? I found a really good quote, and I want to read that to you because I think that is actually the essence, and like everything else, of course you're going to have a good strategy, but I really liked it. And it's like, step 1 is caring about performance of your websites. So step 2 is doing things to make it better. And step 3 is staying on top of performance for the long haul. And that's kind of like what I said, you actually need to monitor and analyze over time. It's not like a one-off where you go like, okay, well, I'm done here. But I think this is kind of the important thing, because like first of all, you have to recognize that it is actually an important thing to do, and that's great because you're here, so you already know that. Step 2 is like doing something about it, which is great because you can do that from tomorrow on, or even like tonight if you're like really into it. And then you just need to kind of like continue staying on top of it. Alright, what do we optimize for? As I said, like we're going to focus on the front end, and for now we are going to focus on page rate, which is like kind of like how big or like how many kilobytes, megabytes, whatever has your page that you're loading. We're going to focus on requests and something called speed index. Anyone heard of speed index before? Or anyone knows what speed index actually is or does? No? Oh, okay, cool. Alright, in your planning process, you need to start planning somewhere. One of the things that was quite popular was like called a performance budget. Anyone heard of that before? Okay, one? Only one? Two? Must be more, no? 3, 4. Okay. Alright, so there's something called a performance budget, and I think I'm not quite sure, Daniel Moore or Tim Tadek or so that came up with that idea. And it basically is the idea of like creating like a budget that you have to stay within. Meaning, you say, okay, page A, I want to be less than 700 kilobytes in total page weight, or you could even say like all my pages should be less than 700 kilobytes. I want to stay within like 20 requests per page and like have a speed index of 1,000. So basically means like, it's like with like a real budget, if you only have like a certain budget, you can't go shopping and like spend more than you actually have. So this is something where you can define up front, okay, this is like what we're aiming for, and then you can always like check back and be like, okay, we're on track for this, or we're not, and if you're not, then you have to like make your sacrifices, basically choosing smaller images or less images, or optimize for staying within that. I personally have really never really used it, but I do have my personal benchmarks, which is kind of like, I don't go after a strict budget, but I have like some optimal thing in mind where like I try to keep within. So when you have that, the important part, or like one of the dangerous things, is design. So there's another good quote which says, design is the foundation of your performance strategy. It defines the user experience and expectations, shapes development, and directly impacts operation. So this is really like a big limitation, something to keep in mind, because if you have a designer that like designs some crazy stuff and you're like, whoa, we need, I don't know, image gradients, for example, because for whatever reason you can't use CSS gradients, it's like going to cost you a lot of budget basically. So you have to steer for that performance already in the design process. And that's why, again, like besides many other reasons, it's important for the developers and designers to work closely together to figure out like, okay, how can we do this? If you want to do this, has like this and this impact on performance. And if it's like too much of an impact, or you know already like, okay, well, this is like going a bit over what I had in mind, then you have to either like kind of work on the design and work with that or change it, or you have to kind of like find other areas where you can make up for it. So it's always a bit of a, well, making a call and like kind of making little sacrifices here and there, where you can find a common ground that works for everyone. So in terms of like project lifecycle and performance budgets, as you can see, so first you have like a proposal, then you have like the discovery phase, and before you actually start the design phase, this is like where you will establish your performance budget. So you set your goals, whatever, so let's stick with the 700 kilobytes, and then you start your design process, and then you always check back with your designers, okay, is this like, can we stay within, prototyping of course helps to do that, but this is actually the point where this should and has to happen. And then again, as I said, maintaining the stuff is like, this is what happens like throughout all other phases, and even like it goes beyond launch, because you always have to check back, okay, is this actually still happening, and is it good, are we staying within? So as we said, like the metrics that matter for now is like page weight, network requests, first paint, and page load. I think first paint I didn't mention earlier, but that's like also one of the ones I want to focus on for now. And again, as I mentioned earlier, I have my own rule of thumb where like I go, okay, this is like kind of what I'm aiming for, and it really, again, depends on the project itself. But in general, I would say I always try to stay way below 1 megabyte. And again, it depends really on the sites and pages and whatever. Sometimes you have like product pages, and obviously you have like many more images than in other cases. But my benchmark is usually like I try 700, maybe 800, depending on the images. Sometimes I get away with like a megabyte or 1.2 if it's like really unavoidable. But it's just a good thing to have in your mind that you actually, oh wow, thank you for the coffee, that's awesome. Where you just like keep in mind, okay, this is like where I want to go. In terms of requests, again, like if you have a lot of images, you also have a lot of requests. But I try to also like kind of keep those as a minimum. If I can get away with 15, which is 15 is very, very low. Even 40 can be okay, but we will see later. That also depends on like many other factors, if that's like a good thing or a bad thing. For now, let's just say many requests are done. And then first paint is basically kind of goes in conjunction with the speed index I mentioned, and I will explain that in a little bit. But that's also something that we want to basically focus on. It means first paint is like the time until the first pixel is drawn, so you want to make that obviously as short as possible, because that's, again, gives the user like a feeling of, okay, something is happening, and even though they have to wait for some other stuff, it can be quite nice if you like, okay, you see something is happening fast. Alright. Then, what I just mentioned now, which I said like, oh, it's going to come later, I don't want to say it because it's actually my fun part. Then there's the reality, and the reality is that most of us usually have clients or stakeholders, and that can be really, really difficult. So I've come across many situations where like, okay, we can't do it because there's no budget. Okay, what do you do? So you actually have to sell it to the client. Sometimes it's difficult because if you haven't done it yet, or you don't have like numbers or stats on it, it's very, very difficult to actually tell the client, okay, if we do this, it's going to be so much better. So you have to kind of like explain them, okay, your ROI is this and that, even though you don't know, it's a bit of a challenge. And you need to like kind of find a way on how to actually get this into the budget. One thing that I'll also show you later, again, speed index is one of them, but there's also something called film strips. This can be used as a selling tool, maybe. It's a good way to show them how bad things actually are. Which is kind of hard to do if you're just starting out with the project and you haven't finished it, because then you don't have any reference points. But then you can go back to all those stats I showed earlier. And there's like many that are like really full on, where you go like, wow, okay, this is a big impact and it might be worth it. But clients and stakeholders can be painful, and it's very difficult sometimes to convince them. So what I do a lot, it's kind of like I take that in consideration up front, and I already know like I really want to do this, maybe not like to the extreme. So what I usually do is like I just don't bother talking to clients about it, or maybe I mention it, but I don't argue for much about it. I just do it as far as like budget allows, and just incorporate it in my workflow, and basically I see it as a default. I want to get this fast because otherwise it's no fun, and don't try to argue with like the client about more budget. I mean, sometimes I do, but like usually I try to like kind of put it into the quote or like the overall effort to actually incorporate that performance part at least to a certain level. So I'm happy with it, because if you want to take it to the extreme, it's going to be a lot of work for very little outcome. So we'll see that, and I think that's a good strategy, because it's like kind of very frictionless and you don't have to argue much, you just do it. So. Alright. We mentioned it earlier, real versus perceived performance. So there's like the hard numbers where you say, okay, my site loads in 2.5 seconds or something. But sometimes it's really difficult to tell what's better. If your like site loads actually faster, like you have hard numbers that are better, or if you actually just give users a feeling of like, oh wow, this was quick. And this is again where like loaders, spinners, progress bars can help, but don't have to. It's a bit of a, I don't know, it's always like kind of depends really on the project. So as you can see, like many things, it's every project is different in a certain way. And you just have to find your perfect solution with the site as fast as possible. And then it's also good to get some testing done, to get some validation, because otherwise you only have your own opinion, and that can be sometimes like tricky or even not the right one, because you've been looking at it for so long. Alright. Any questions so far? Can you hear me all okay? Because I realize sometimes I move a little bit back and forth, but it's okay. You guys can see me over there? Alright. to stand over here for a bit? Yeah, awesome. Cool. Alright, now we're going into analyzing your project, because like now we know, okay, how to plan for it, and then we need to analyze. So we want to find out where your bottlenecks are and all of that. So it's basically about like testing for performance, personal preference, but then there's like some basics. They're all the same in all the different tools. Even like there's like online apps and stuff where you can also test things. So I'll run you through those, and after that you should have a fairly good understanding on how to look at things, how to interpret things, like how to see, okay, where's my problem zones, and so on. So the first one is actually called waterfall chart, and I'm very sure like many of you have seen that. So how many have seen this before? Okay. How many of you like use DevTools on a frequent basis? Okay, cool. That's also good. I thought it would be a bit more, but that's good. Alright, so basically the waterfall chart is like a chart that like displays all of your resources you have on your site, and it shows like what exactly is happening at what point. So again, this is like part of what I showed earlier. So first you have like the DNS request, then you have like the connection, then you have like SSL handshake if you have a secure site, and so on. And it goes like basically through all the different resource types that you have. And then you can see like the first one is always your index HTML, and then after that it goes like in a certain order. You can change that order by like load time or resource timing or start time, end time, and so on. But basically every of those resources tells you, okay, this is how long it took to connect, this is how long it took to load it. So this is like what those bars represent. This one is from web page test. So, but like basically all the charts are the same. And I actually also believe like the colors are standardized as far as I know. So this one would be the waterfall chart in Chrome DevTools. And you can also see like you have those resources there, right here. And then you see how long they've been loading. This is like a secure site, so the purple stuff is like your SSL handshake. And you can actually see like how long everything took to load and in what order. Then there's an interesting, you see those two lines in there? Is that little blue one right there and the red one back there. So the blue one basically says like when the document object model is loaded. So this is basically when your DOM ready JavaScript event fires. That's like when you can interact with the page via JavaScript and stuff. And the red one is like fully loaded. So these are like two really good ones to remember, and we'll come across them like much or like more often. And you can also see in this one, right down here, I don't know if you can see that actually very well, but like if you open it in your browser, which you could actually do now, you can see like there's like a blue number and a red number, and these like basically refer to the blue line and the red line. And then you have like the option of sorting those. So as I said up here, you can like actually say like, okay, sort by response time, start time, end time, I don't know what else, like a few things. So that gives you like a bit of a different sorting order for that. It can be quite interesting because you can see different things. Okay, so then there's also resource timing, what I mentioned earlier. If you like hover or click on one of those bars, you actually get like a bit of a summary on what's happening with that resource. And you can see there's like a lot of stuff that you can see there. There's like queuing, it says like how long it has been installed, the DNS lookup for that resource, initial connection, SSL, again if it's like a secure site. And then you have the actual request response. How long it took to send that. Time to first byte is also quite a bit of an interesting metric. And then you have the download time, so the blue, and you can also see like the colors refer to these colors here, so you get like a good overview on like how long it takes for each resource to do whatever they do. One of my favorite things is in this one, also you can up here, you see that? You can actually input like a throttle. Basically, you can slow down your connection. You can say, okay, I don't want my normal broadband that I'm on usually. You can actually say, okay, change this to, I don't know, a 2G or a 3G connection, and it will slow down everything. That is really, really helpful, because if you're always just in your office and you have like a, I don't know, crazy broadband with like 500 Mbit download, it's always nice, it's always great, it's always awesome. But like if you really want to test, even like for local development, if you have the site on your local machine, you can even like throttle it there and you'll get a very, very different view on things. So that's one of my favorite things. And if you have turned that on, you'll see there's like a little exclamation mark next to network. And that is good to have, because like when they introduced this, the exclamation mark was not there, and sometimes you would be just like, oh wow, my connection is really, really slow today, and sometimes you just forget and you're just like going crazy on like a 2G connection, and at some point you would find out, okay, well yeah, maybe I should turn off the throttle. So it's actually nice they have that now, so you realize, okay, it's on. There's another one which comes with like Apple's Xcode. It's called Network Link Conditioner. Basically does the same thing. That's what we used before Chrome introduced that. Does the same thing. You can also like enter your own presets if you want to, but it has like a few different ones in there already, like from broadband to DSL to dial-up and so on, 2G, 3G, good 3G, bad 3G, lossy 3G, whatever, like all kinds of things. So you can basically simulate a lot of different networks. Okay, so much for this one right now. Then there's another tab in Chrome DevTools, which is called the Audit tab, and that looks something like this. So you can see like there's like the different tools up here. The first one is like your element inspector, then you have the network, and then back there is audits. If you like audits further up front, you can also rearrange those by dragging them back and forth. But the audit one is also quite good. Can help you like get a good understanding also on what your site does. And there's like two ways you can run that audit. Once is like with a reload, or like on the current state of the site. If you run it with the reload, it basically reloads the page and it gives you like all the server optimization options as well. If you don't run it with the reload, you only get like basically the local site optimizations. And then once you run that, it looks like this, and you get like certain suggestions of like what you can do. One of them is, for example, like minimize cookie size, specify image dimensions. I always kind of like disagree with that, because nobody does that nowadays. But it's kind of like in the spec, but this is one of the ones I always ignore. I have never tried out how much of a difference it would make, or if it even makes a difference. Not a big fan of that. But the interesting one on this one is actually, it also tells you like how many unused CSS rules are in your file. And this one is killer, and it's going to be quite funny, because like if you run that on like various sites, sometimes it's a bit interesting to see how many unused rules you have. Especially if you're working with like something like Bootstrap or Foundation, there's like a lot of stuff in there. So this is an important one. I like to use that a lot. Then you have the current state one, which basically then only gives you like a few options. But these are always quite good to look after, whereas like I have to admit, I don't always go after all of them, unless you want to really take it to the very, very crazy level. Alright, so then I mentioned web page test, webpagetest.org, looks something like that. It's very, very ugly, but it actually does a very, very good job. So you can just input like any site there. If you want, if you have your computer in front of you, just go to webpagetest.org, and you can just let run enter like any domain. You can choose like a server location, and then it will spit out like various things for you, like one by default, like the waterfall we looked at earlier. And then it has like a really, really cool feature. That's what I mentioned earlier with the film strip, because like once you ran that, and then you can like actually view the loading in like a film strip, which looks like something like this. So you can specify like what duration of frames you want and all of that, and it basically shows you, okay, this is how the page loads. And this can be quite insightful. Very, very cool. And if you don't like pictures, there's another really cool thing, because you can actually export a video. Was that? Yeah. And it's because like usually if you do that you wouldn't see that, but I really like this video feature. And you can see Manila Times is like not the fastest. Do you guys actually read that? Like Manila Times? No? Or the Standard? Also, is that popular with you guys? Or not really? Okay, guess not really. So more like Facebook, huh? Okay. Okay. Speed index. I mentioned that before, so now I want to explain what that is because it's actually quite helpful as well. So speed index was created to like get a metric that like kind of shows you what's happening from like a more like a user's point of view. And is it double? Yeah. And basically it tells you the time the visual parts of the page are completed, and that's like only above the fold, basically like the part that you can see of the page. So it only takes in consideration like the visible viewport, and then calculates the time of like visual completion. And to explain that a bit better, there is a table right here. So you can see, let's say your site would load like, okay, 100 milliseconds, there's like 0% of completion. It's kind of like what we've seen in the video, and then it goes down, and the further it progresses, like for 700 milliseconds, it's like 45% of the visual viewport is completed with rendering, and then 1200 milliseconds is like 100% complete. So this is like, you would be like a speed index of 1200. And if you look at that in a graph, it would look something like this. And the interesting part is basically the part that is, the part that is above the graph, basically meaning this area, is the visual explanation of like the white space the user sees. So the more area you have above that graph, which is something like that, the longer it takes for the user to see something. So you want to try to keep that area very, very small. So in comparison, we have another table, and you can see like for this one, it would be like 200 milliseconds, it's already 20% complete, and then it goes all the way down to 1200, and that graph would look something like this. And obviously this is much smaller, so much better for the user because it's less white space, like they see stuff earlier, and so you want to try to keep your speed index very low. So if you can get that to like 1000 or 1200, it's actually quite okay. Then another one in Chrome DevTools is the timeline. This is a bit of a full-on tab. There's a lot of stuff going on there, and this is a bit advanced. I'll also have some resources which really like explains that in detail. I'm just gonna scratch it a little bit because otherwise it's like too much information, but it kind of looks like something like this. So you run the site, you reload it, and it gives you all kinds of information. So up here you have your timeline. The red boxes here basically mark where you might have problems with like jank, which means like not smooth scrolling and all of that. So you've seen that before? I think that's a bit crazy one. It takes a long time to really fully understand that and make use of it. But it basically analyzes like memory heaps for JavaScript, where like your frames take too long, where there's like too much processing going on in a certain frame. And if that happens all the time, I'm sure you've all seen that if you have like crazy parallax sites where like stuff happens on scroll and stuff, sometimes the scrolling is not smooth. So that's like called jank. And you will see like a lot of red boxes in there, and this is like where you then can optimize. If you have like on scroll handlers or stuff like that, then this is what happens. Then you also have like, you see, it says like 60 FPS. So the green stuff is like where you reach 60 frames per second, which means like it's like all smooth and like all smooth scrolling. Everything that goes above that will be kind of subject to, could be a problem. Now they even like give you like little error messages, and that's quite cool because before that was not. But now they actually tell you, okay, this is like 13 seconds. Can you actually see that all right, or is it very, very small? It's kind of small. Do I have another one? No. So basically, you hover over one of those like little boxes here, and then you get like a little info box, and it says, see, I can't even read it. Forced reflow, it's likely it is likely performance bottleneck, and this like also happens like if you have to recompute layout all the time and things. It's a bit a shame it's too small. But if you open it up in your browser, because you have that right in front of you, you can actually see that. Okay, so lots of things going on here. Then you also see you have that message up here that I just mentioned. Then you also get like more info in the summary, and you can like click through these things, and you can actually analyze, okay, which function of your JavaScript triggered that message, and so on. But as I said, it's a bit advanced. We're not using that today so much, but it also can be helpful if you like have JavaScript applications and you have like really like whatever jaggy scrolling or not smooth animations. Then you can figure out, okay, this function call actually triggers that crazy overhead. This one is pretty much the same. In the middle, I didn't mention that, these are all your resources, and you can again see how long they take to load. So it has a lot of information in there. I think Google came up with like a formula for that, and it's called rail approach, which is response, animation, idle, load. So these are the values. When like you reach those, you actually know everything will be pretty much fine. So it's response time 100 milliseconds, animation speed 16 milliseconds, and that's like when you reach 60 FPS, frames per second, and everything will be smooth, because like 16 milliseconds of processing is exactly what fits into one frame, and you just don't want to have like whatever functions that like need a lot of time to execute or process. And then idle time 50 seconds and load time is 1 second. So this is kind of like the overall metrics to go for. Can be quite daunting, but in general, like what we talked about earlier, said speed index of 1000, and like you have your page weight below X, is kind of like going hand in hand with that. Then another tool is Google PageSpeed Insights. Basically, simple web page, input your URL, and it will give you a lot of analytics about like what your site or where the problems are. There's another one which basically sits on top of that now, is this one, also Google. This is quite nice actually. Also input your site, then you get something like this. And it tells you, okay, this is mobile friendliness, mobile speed, and desktop speed. So I actually have to work on that. You can also try that out if you want. And then like it breaks it down like into more explanation if you scroll down on that. Another one that I personally don't use that frequently, but it's kind of cool, is called perfmap. Perfmap is like a bookmarklet, little script that actually overlays all your images with like the load times. It's a shame you can't see that, it's a bit sad. But you can also check that out. It's quite interesting to see because it basically tells you like all the images, and this one took so long and so long and so long. Then the next step is like something called Navigation Timing API, and that is really cool. It's been introduced not too long ago, and this one is actually killer, but it's quite advanced. But you can do a lot of stuff with it. Basically, it's an API where you can dig into and get like all kind of values. I mean, you see it's like 21 events basically, and those usually come back as a Unix timestamp, and then you can do a lot of calculations with it. You just have to know which ones are which I'll explain in a little bit. But let's say you can subtract or add different values, and it gives you the load time or time to first paint and so on. It's really powerful and really cool. And they're now introduced a new one which is called like high performance timing or something. And then there's also another one coming like it's called resource timing, which gives you like values on all the different resources. So it's very cool. And if you're like familiar or like comfortable with JavaScript, you can also just type that right into the console in your browser, and that looks like something like this. So you can just, as you see, you want to get the load time, and you just like take the load event end and subtract the fetch start, and that gives you like the total load time. And you can do like a lot of calculations with it. Luckily, there's people who actually do things with these things, and Adi Osmani did like a very cool bookmarklet, which is one of my favorite things to use. It's called timing.js, and what that does, it basically has all those calculations in it, and it throws you like a table into the console, and then you get all those values like printed out, so you actually don't have to bother with like doing the calculations by yourself. It's quite helpful. And you just get like a lot of like values. Basically, I use it like mostly for the first paint value, because like everything else you get in the dev tools as well. But you can see first paint time, and that's like 3.29 seconds in this case. Pretty bad, but also depends very much on network sometimes. But this is, as I said, like one of my favorites and definitely worth installing. Then when you're using that, sometimes you see, well, this is how it looks like if you type it straight into the console, by the way. And sometimes you have like little differences. For example, up there it says like load time 890 milliseconds, and down there it says like 895. Sometimes there's different calculations. It changes once in a while, so the browser vendors like calculate differently, or they change the calculation for whatever reason. Then the timing.js like gets kind of like fixed as well. Or sometimes it's also due to rounding errors, or like not errors, but like different ways of rounding. So usually I don't care much about those little differences. I mean, it's like, it's okay if you know it's like 890 and some, so I'm okay with that. Okay, so now that we've looked at all these things, you can have 5 minutes to actually open any one of those tools and just like check it out a little bit. I'll have a little bit of water and coffee in the meantime. So you can either use like webpagetest.org, or you can just open your browser. You can open the DevTools either by, you can right click on any element and choose inspect element, that will open it, or on Mac it's Command Option I will open your DevTools, or on Windows it's what? I don't know, probably like Command Alt I or something, I would suppose. Anyone knows? Pardon? Is what?
F12.
Oh, F12. Oh, that reminds me of Internet Explorer. Alright, so just have a look at that. You can have like a quick go on, like just pick any site that you like, your own, or like any, just have a look at like what comes back, and then you can try out the different features like film strip, and you can have a look at those, and then we'll resume in a few minutes. Alright, let's continue. So seems like more people are interested in getting coffee. But if you have a look now in like any of those tools, I think you have like a bit of a feeling like what happens, how does it look, what can you do. We'll get a bit more into detail later as well. But this is like the main tools we will be working with, or like that you will be working with from now on, because like that's like where you get all the information that you need, and then you can act on it. So again, you have those tools like on board, you have those like for your daily optimization stuff, and then as I said, like you also need to keep track of things like over time, and like track your process progress. There's like performance monitoring services. Basically you can set up like different metrics that you want to watch, or you can even like compare to competitors and get alerts when your metrics go down south and all these things. It's quite helpful. I personally don't use it as much, because they're like all like paid apps. If you have a client that actually pays for it, that's like cool. I can only encourage you to use those. It's fairly insightful. You get graphs on like, okay, daily activities, daily performance metrics, and so on. You can set up whatever you want. One of them is called Speed Curve, and then there's another one which Sophia I think mentioned earlier, which is called Caliber app. So they're kind of very similar, but also very worth looking into. So much for like analyzing the tools we're using for now and monitoring. So as I mentioned earlier, getting to the low-hanging fruit is like putting in very little effort, getting very big results. So that's what we're going to focus on now. I hope we can get through with that until lunch, but let's see. So one of the things I notice a lot is, and it's kind of like I always feel like a little bit silly like even mentioning that because it should be a no-brainer, but images. Images account for like the majority of bytes on any web page, unless you don't have any, but that's hardly the case. And it kind of looks like this. So yellow, oh this is a bit screwed up, but this average bytes per page by content type, and you can see yellow is images, and everything else is like HTML, CSS, video, and JavaScript. So images do have like a big impact, and it really bugs me that headline is off, but what can you do? So you want to optimize your images, and a lot of times like I come across sites where it's really not the case, and you can like have so much like gain on like getting your images right. You're almost halfway there. So let's have a look at that. I'm sure you cannot, definitely not read this then. So basically you want to compare different images for certain size and quality. You want to find like an image optimization strategy, how to work with those. That can be like tools or task runners. Image optimization tools can do a lot for you. And as I said, there's like sometimes ways where you cannot really control all of your images, and you want to find out, okay, how do you best get those images sorted. Wow, there's like a lot of... Okay, so sorry all these like are kind of like screwed up because like I had to change from 16 to 9 or to 4x3, and apparently these fell through. What you have to do in the first place is like kind of you have to find out or like look at your images, and you have to make a decision on like you want to go for like big ones or smaller ones and make a call on that. There's also then the questions, do you want to optimize for retina or not? And this is something that is actually quite interesting because especially with like retina or not, I find like there's like a lot of middle ground where you can make a lot of weight. So instead of like going always like double resolution, you can also like opt for like 1.5, and you might even like get the same like visual results. Sometimes it even makes sense like to go for bigger images and squish them down, but like keep them at like 1.5 and they look just fine. And if you play around with these like different options, sometimes you'll realize, okay, wow, this is actually much smaller, even though it's like a bigger image, maybe at like a lower resolution. It might be like much smaller in file size than an actual like retina image, which is original size. So this is like something where you can actually really experiment with a little bit. For example, this is an image like 1000 pixels and it's squished down, but you see like even image compression can make a big difference. So at 80% you get like 150K, and if you go down to 50, it's like 57. It's a bit hard to actually see the difference, but even if you open those images, the difference is so minor, almost none. So I usually try for like 60% JPEG compression, and most of the time is actually really okay. Instead of like just taking your JPEG as is, because then it's like probably like at least double the size. So many times the case, such an easy thing to do, like optimize your images, and you might like halve your bytes already. So very worth like having a look at those. There's lots of tools for that. My favorite is actually Image Optim. Very cool, comes for free, simplest tool ever. You just throw your images in there, it does the magic, and it gets like a lot of bytes down. I mean, it sometimes depends a little bit on the image, but I would say like somewhere between like 3 and 20% lower file size. And when it comes out, it kind of looks like that. So this one only has like 10% roughly. But at least like even 10%, and it chooses like the compression algorithm by itself, like whatever is best suited, works for JPEGs and PNGs, so I can only recommend that. And if you don't like that tool, you can also use that with like Grunt or Gulp, and it just like run your task and it goes like spits out your images, and you're done. So very, very easy to do. Again, one of the problems, clients, stakeholders, whoever runs pages, I had clients like they upload thumbnails in original file size, and a little thumbnail like whatever 200 by 300 is like a megabyte, and I'm like, wow, maybe that's not the right way to go, but it does happen in real life. So you always have to, again, that's like the monitoring part, like what happens after launch, educate clients to actually be aware of that, whereas like most people don't understand how to do that. But seriously, this tool, like even my mom and whoever can use that, because it's so simple. It's just like open it, drop your images on there, and like you're done. Very, very cool. So one of my favorites. Then you also have, I'm sure everybody has heard of SVG by now. So scalable vector graphics, very good for like logos or like image types, I would say, that you would usually like opt for GIFs. You can also use vector images, fully scalable, very, very small in file size. Depends a little bit on like browser support, what you have to deliver for, which browsers you have to support. But in general, I think support is quite good by now, and you can use SVG instead of like GIFs for your logos or icons or something, and it will also make a big difference. Then there is like sprites. You could use image sprites, basically a concept taken from video games. So like you have one big file that includes like a lot of images, and then you just move this file around with like a little viewport, and you're specified in your CSS. So I'm sure, I don't know, who has used sprites? Okay, so that's like a fairly well-known thing. I rarely use them because I think it's just like very painful to use. But if you have a lot of those, and especially like this one, Facebook, they have a lot of little icons everywhere. They used to have a very, very big sprite file. Now they have like different smaller ones. But this is basically how it looks like. And then you specify like a little viewport. So you would only see that area within that red. And then you just move the file basically within that visible part. So that's like how sprites work. Basically what happens if you use sprites, you're reducing requests and you only need one HTTP request. So this is like why this is like a useful thing. If you have like 200 icons, you don't want to have 200 requests, because like every request takes time. So you can kind of like optimize on that. And speaking of the requests, every request takes like a certain time, can be up to like 300 milliseconds. So if you like multiply that by like, I don't know, 200, is not very good for your performance. So sprites is one way to optimize on like limiting your requests. There's more on that. Some drawbacks. It's just harder to maintain and update. Increased memory consumption. All of these things. I think it really also depends on like how you want to use them, or how many images you would have otherwise. Then there's also another technique which is basically based for 64 encoding of images. You just like throw them right into a data UI or inline. This can be very good because you're basically delivering your image with your HTML page, which is like the first request. So it goes like right out. It's usually a little bit bigger than the actual binary image, but it can make it quite a big difference because it comes with the first request and it's right there. The drawback, or one of the drawbacks, for example, is that it's not cacheable. So every time you load that thing again, like you have to actually load those bytes again. But again, depends on your project. It's definitely worth trying out. I tried all these things. Like in the end, with one of the projects, I went for a PNG instead. But that's like kind of, you really have to try it. And again, like it doesn't work the same for every project. You couldn't say like, okay, this is always good or this is always bad. So yeah, and that's also another one is not indexed by Google because it's like inline. Oh, it really bugs me that it's kind of off. Okay, this is also fucked. Anyways, this is like how an image looks like as an inline base 64. So this would be the image. It looks a bit scary, but you can also, if you wanted to, you could also automate that with like PHP or Grunt, Gulp, whatever. A lot of possibilities to actually like throw those out with like dynamically. this was like a quote I found. We're measuring the performance of hundreds of thousands of mobile page views. The loading images using data URIs is on average 6 times slower. I think this is a little bit outdated, but again, depends on your project. You can really you have to try it out. Sometimes it can be slower, sometimes you can have huge gains and so on. Other than that, you can use SourceSet and deliver different image sizes for different viewports. That's also a good way of optimizing it. Especially for mobile, you just deliver smaller images than you would for desktop, so that's fairly straightforward. Then another one would be lazy loading, whereas you only need the images, or you only load the images that you actually want right away. Everything that's below the fold or so, you would just load a little bit later. Usually a lot of people load them once they scroll into view. I actually prefer if you set an offset, and let's say you load images that are 100 pixel or something below the fold. So you have your browser window ends here, and you start loading the images once they're almost there, and then they will appear once you scroll into it. Because otherwise you have that effect that you actually really, you're lazy loading and you're saving on the data, but then you scroll up and you have still see loading images. So I don't really like it, not a big fan. So it's a bit of a smarter approach to actually set an offset of whatever you want, and then go from there. It's quite cool how Apple does it nowadays, because on their iPhone side, or the pages, they have before they have delivered massive images, and I think the last one, I think that was in 2014 or so when I was here, the iPhone pages were 30 megabytes or something, completely insane, all the big images full on. Now they're actually doing lazy loading on that one, and they're delivering different sizes for different viewports, so that's actually much more efficient and much better. You introduced not too long ago is kind of the blur loading. So you actually load part of the image, which gets blurred out. You load that full one. Once the full one is loaded, that other one gets replaced. This is really cool. I kind of like it, whereas I've heard a lot of people with really slow connections, they basically never see the original full image, which is a bit frustrating. So maybe not that good. And another article that I would highly recommend to read, just because for its geekiness, is from Facebook, how they load their cover images now. That is absolutely insane. And when I read it, I was I can't believe people actually do that. But what they've done is kind of, I think it's 12 bytes or something. So they fit the first request, the page, plus an image into tiny bytes, and they deconstructed the JPEG header table and all that stuff. You read it and you're just wow, actually that is full on insane, but very cool. So basically the same thing. I think that picture on the left there that you see, the blurry one, I think it's something, I don't know, it's very tiny. I can't remember how big they're actually loading that picture and then stretch it out and blur it, but it's fantastic, and it's 12 bytes or so, and fully goes into the first round trip, and pretty amazing. Unfortunately the URL is not seen, but it's on the Facebook developer blog, and I think if you search for preview photos developer Facebook, you'll find that one, and it's really worth a read. Very cool. Okay. And then also there's more on advanced image compression techniques. There's a nice talk about on that from Tobias Baldorf, and you can find that on YouTube. He works for Akamai, and if you Google for that one, you'll also find it, or the link is also in the slides, so I can provide that later. There's it goes about different image formats WebP and JPEG 2000 and all that, and how you actually get those to use. Very cool. But that's also a bit more advanced. If you really want to go for what I said, the low-hanging fruit, you just stick with the first part of that image section, and it should get you very far. Alright, then we also have cultural change, and that's a bit of a challenge, because you have to, what I mentioned earlier, you have to make your client aware of actually, okay, hey, this is important, take care of it, we need to take care of it now, and we actually have to kind of take care of it after the project is launched. And that slide mentions what I said earlier, like client uploads like little thumbnail and it's like a megabyte and just like want to cry, but that's like also something to explain to client stakeholders that like they should take care of images and not like upload their print files. Alright, so now we can move on and we'll talk a little bit about optimizing your CSS files and JavaScript and web fonts and all these things. And one of the reasons why I asked before, like if anyone is working with frameworks, is usually when people are working with frameworks, it's like, okay, I'll take this out of the box, add my stuff and my site is done. And this is not quite how it should work. I would generally not say like the frameworks are bad. I mean, there's a lot of people who go like, oh, don't like Bootstrap, don't like this, don't like that. I think it's totally fine if you want to use those, but you need to know how to use it and you need to actually know how to optimize and like get rid of the stuff that you don't want. I mean, it's a nice starting point and you can like do really cool stuff with it, that's fine. But it offers so much like functionality out of the box, and if you don't use that, then make sure you also don't use like the corresponding CSS, JavaScript. You can just get rid of that because it's going to make your end project much faster. So what you want to do is like maybe have like your own CSS file that you hook into the partials and then throw out everything you're not needing. And you can actually see that again with like DevTools Audit. That's like where you can easily find out if you worked on a Bootstrap project, run that tool on it and it's going to tell you if you've done it right or not. It's quite interesting to see. I have a few screenshots later which is quite fun to look at, and then you already know, okay, done it right or there is like room for optimization. One of my favorite tools is called uncss, and that's like perfect for those like framework problems because basically it does what it says. It throws out unused CSS rules, and that is awesome. Very cool. It's a bit of a tricky one sometimes because first of all, it doesn't work with like dynamic files anymore, so it doesn't take like PHP files anymore where like before it used to. And for dynamic classes that you add via JavaScript, you need to add them via like manual process. It can be a bit tedious, especially if you have like a lot of classes that are set by JavaScript. It's very difficult to actually keep track of all of them, and then you have to like list those out extra so they get included. Otherwise, they'll be the rules are gone and like nothing happens when you trigger your JavaScript. So that's a bit of a problem, but for many projects it works really well. And as I said before, run DevTools Audit, and some pages will give you this. And you find like, okay, wow, there's like 15,000 rules in my CSS file that I'm actually not using. That can always like vary a little bit because you're just testing it on one page. Maybe you have another page which uses like those 15,000 rules, but then you've done something wrong on the other end. But generally, this is like way too much. So if you optimize a little bit, it will probably rather say like something like this. It's like 800 in this case. Yeah, okay, maybe, but still a little bit much, I find. So if you're good, then it's probably more somewhere around this range, like maybe a 50, 20, 100, I don't know, not too dramatic. So I worked on a project a couple years ago, like which was like kind of like a fun project for myself, and now it kind of like turned into my performance playground where I just like kind of try out things and new techniques, and then I just like have a go at it. It looks like this. So for this one, this is actually built with Foundation, and the initial development file, the CSS file that went in there was like 86K, so that's like fairly big. And after running uncss and like optimizing it, it actually went down to 12 kilobyte uncompressed, which gives you like a gzip size of like 3.8K. So this is like a result where I'm like, okay, this is like something I can work with. So basically you go down from like 80 to 3.8K, that's a fair size. So uncss like does work wonders if you use it in the right way. As I said, like sometimes it's a bit tricky to implement it. What I'll sometimes do to get around that, like it doesn't take dynamic files like PHP or so, I basically scrape the whole site or just copy like all the rendered HTML code, put it into one file, like very, very dirty. Like I even like take the headers and everything like from every page and like just throw it into one file, throw that one file into uncss, and you basically have all the rules site-wide. Or you could even like scrape the site and put all the single HTML files in there. That's also very good. Then you only have to take care of the classes that are set by a JavaScript or something. Which, in case you have too many, I don't know if it makes sense, but for like a few, it's always like a feasible solution. What else I do is like usually run like very different other tools, like Nano, for example, is like the same as CSS min. UnCSS, then you concat it and you lint your CSS, same for like the JS. You want to combine all that stuff, uglify, basically make it all compressed, and then you can actually gain a lot of that, like a lot of improvements on that as well. Commerce platform, and they like inject like a statistics analytics file, and then they give you like another one. Then you have like a kind of JavaScript based functions that you can like use with their backend and stuff. You cannot do anything about that, they're just there. So sometimes maybe they're not compressed, so you can compress them, you can concatenate them with other files, which gives you like some other like more requests. It's a bit annoying sometimes, but still if you do everything else okay, it's like still not too bad. But these things like really bug me sometimes because it takes control away from you, and then you just don't know what to do about it. So you have to actually go with that. Then we also have like web fonts, and web fonts is again another resource that like can take up a lot of page weight, or like can produce a lot of page weight. The problem with like web fonts is that they're actually not being cached, so you load them on every site, and it's very difficult to make a call on that, because sometimes you pick a font and like, let's say your font file, you want like a normal one, you want like a bold one, and every style comes like in a single file. So every style of the font like requires you to load one more file, which is in addition one more request. And then you really have to think about, okay, what sacrifices do I want to make? Some fonts are like massive, like it's a very big file. What Kendra said yesterday, like the Chinese font file would be like 7 megabytes. I mean, that's like out of the discussion. But there's like bigger ones and smaller ones, and sometimes you really have to think about like, okay, is the visual aesthetics like actually worth like an extra 100 or 200k? Many times I just pick another font that maybe is similar, or kind of like also works for me, just because I can like reduce file size for the font files maybe from like 150k to like 50. So I'd rather go with like a similar font and save on the file size than the other way around. But again, that's your judgment, and that's like a call everybody has to make, and choose what you want to use or how you want to do it. Sometimes like clients might insist, but then you can like still try to argue about it. But again, mileage varies, personal preference, also depends on like your opinions on how you see those things. Maybe you can make up for those like 100k in something else. Alright, then there's also cache. We talked about it briefly earlier. So there's a lot of things you can do with your cache. So it's basically about like setting your caching values right. That usually can be done either in your htaccess file. If you have access to the server, you can also do it right there. Generally, it's very good to set like cache expiration dates for CSS and JavaScript, and it kind of like depends like how much your stuff changes, how long your expiration date should be. But there was like a very interesting article, I think last week, from the BBC, how they're using caching. I don't know, have anyone read that? Seen that? It is also very, very cool how they do that, because they're basically trying to take advantage of the cache in a way that they're like, even if they would usually serve personalized pages, where it says like, okay, I don't know, hello Sylvia, you view your account or so, they would actually just render like a general page, which would be the same for every user, so you can actually pull that from cache, and then they would like change the usernames like in the front end. Basically client side, flip that, so you can always like pull from cache. So that can also make a very, very big difference. Very cool article also on how they're making use of that. But if you set your cache right, it can also make a big difference on certain things. Alright, any questions so far? I'm sure there must be questions, because otherwise I would say we have like a lunch break in like a few minutes. I mean, we're running a little bit early actually, surprisingly. But maybe we can have a few questions and like maybe we can, I don't know, discuss a few things here and then we can have the lunch break. Yeah, please.
Got just a question about JavaScript loading. So first, there have two terms that we can use in JavaScript loading. First is concatenating the JavaScript files and load it in one or two files. And second is asynchronously loading of the JavaScript files. So what are the advantages and disadvantages between those two types of JavaScript loading that we can maybe use in our further projects?
This is something we'll cover like in the later part as well, like a little bit more on like the async loading. But maybe one thing I can add to that, like usually, whereas like that's also kind of like coming after the break, but I can already tell you, like usually you would try to load the JavaScript if you're going for like HTTP1, you would try to load your JavaScript at the bottom of your page, unless you really, really need it right away, because it's render blocking, and since you don't need it right away, you can actually load that at the bottom of your page, whereas like the CSS needs to go at the top, otherwise you get like the flash of unstyled content and so on. The reason why we want to concatenate is like that you want to limit your requests, and I mean in the end it depends really if you have like 1, 2, 3 files, whatever, but generally I think it's a good idea to just have one, unless that's like massive, and again that like depends on your case and is all like a bit of a personal test case, you know. But generally you want to try to reduce the requests, as we said earlier, because every request takes like a certain amount of time. The more you have, the longer it will be. And yeah, I think that's pretty much it. And I don't want to go too much into like what's coming later. But try to load your JavaScript at the bottom of the page instead of like in the head, and then it doesn't render block your page. Does that answer your question, or?
Yeah. But I also have another question, though they're not about JavaScript. It's about cache. So can I ask your opinion regarding using service workers in managing the caching of your project?
Honestly, I have to pass on the service worker because I haven't actually tried it out. I always wanted to recently, but I didn't have time to properly set it up. Maybe you have some ideas on that. I'm very sure you do. But I can't like really answer that question because like I haven't tried it out and I don't know how it works with the caching and stuff. But do you want to say something to that? Do you know? Maybe you can answer that question. Yay.
Okay, so he knows. So I've been playing with Service Worker along with Polymer recently. So with Service Worker, the idea is it's the one handling the caching for you, but that's good for production but not on development. So the only thing that I can say for now is if you're going to develop using Service Worker, just don't turn it on for now. What the good thing with Service Worker is you can, like, if you have one JavaScript file that is concatenated and uglified, you can load it as your first JavaScript file, and that will be cached already. And then you can also load several other JavaScript files that is for lazy loading, but most of it will be another talk in a sense. It's like a really different way of doing it. So it's a big talk in a sense.
But maybe that gives you a little bit of an idea. I think that's like still like a very I mean, I think many areas in like terms of service worker, it's like all kind of like a constant work in progress, and I'm sure it's going to change like quite a bit. So, but do you want to add something?
So I just remembered, if you're for us, we usually have like right click on the network on the dev console and right click and then just disable cache for just disabling or not disable or reset everything, cookies, cache. If you're using service worker, there's another step for resetting. Because I have this problem recently where I was coding and then changing, and I forgot that I installed service worker, and I was like, why is it not changing something? So I have to invalidate the service worker altogether. It's in another part of the dev console. So yeah, you can come here and show it to you guys, but that's the thing. It's a different topic. It's good for caching, but good for production only. And you have some kind of gulp file or whatever it is that you need to do just to compile the service worker.
Thank you very much for that. Awesome.
Can I add a follow-up question for Mr. Gugulayo? So, okay, in terms of, yeah, I've read a lot of, articles regarding service worker, but most of them are using Polymer in implementing the service workers. So, is it possible that we're still not yet adopting the Polymer or the progressive web apps of Polymer? So since let's say for example we're still developing in a sense of simple JavaScript files and then so is it possible that we can use the server worker technology in our current tech, for example?
Yes, you can. One quick tip is you can read the service worker APIs at Google. They will teach you how to code the service worker and how to register it on, like, when it loads on the index.html. You can read it up. There are some people who are already putting it on Webpack for React.js. So it's not only for Polymer. Of course, Polymer has already done it. Like, you just type Polymer build and it will also build a service worker. But there are other things out there for like using it even on simple jQuery and vanilla JavaScript.
Thank you. Any more questions for now? Anyone else?
Just want to ask, let's say your website has 10 pages. You go one page, but that one page is very CSS for all the other 10 pages. So there will be unused CSS. So how do we go about that?
So the question is like, if you have 10 pages and you have like one CSS file for all of them, and how do you go about it with that you have unused CSS for the other 9 basically? I mean, that's like kind of, there's always an overlap, I think. I mean, you're not going to have like too much unused because you're trying to like share common modules or so. I don't think you have to go crazy about the unused ones. It's more like if you have really like 15,000 unused rules, that's too much. If you have 15,000 rules in your CSS file, too much. Unless it's like a massive mega platform, but I don't think that's usually the case. It's more about like getting a feeling for like roughly the numbers. I mean, like if you have like 50 unused, that's like very small. If you have like 200 unused, that's like also very small. It's not gonna make like a substantial difference. It's more like getting like the difference between, let's say, a CSS file that's like 170K versus 30 or 50 or whatever your project needs. So it's not about like going after every page. You could do that, but I don't think it's a very smart approach. It's more like getting a feeling for like, okay, this is like too much and this is okay. Because I don't think it makes a very big difference in the end if you're loading 30 or 50K CSS. I think it's should be kind of like somewhat in the same range. It's more about like getting or filtering out really like the extra 100K that you really don't need, because that's like massive overhead. It's not about like the tiny bits. It's more like the bigger picture. So yeah, I usually wouldn't. I don't even know. Like I probably wouldn't worry about like 200 unused or so. You know, it's more like kind of getting the other 15,000 away because that's too much. Basically, saying if you're using a framework and you have like 20 module includes and you know, okay, I'm not using the tabs, I'm not using the labels, I'm not using the accordion, I'm not using X, Y, Z, whatever, you don't want to include those CSS files or partials into your project because you actually already know you're not using them. So it's more about kind of these things, like as in opposed to 9 pages might have a few different modules than like the other page. It's not about that. It's more like getting the really like stuff that you really know you don't need out. And I mean, same goes for the JavaScript, especially with like frameworks. If you have like, again, tabs, accordion, if you know you're not using that or you know you don't need that, don't include it in your project. Yeah. Cool. All right. Anyone else? One more question, then we can have a little break. I think lunch break. Everybody enjoyed lunch? Nobody falling asleep now? So, and to make sure you're not falling asleep, we're going to start off with like a little exercise, and it's going to be a little group exercise. So just to make sure you're not like kind of lacking off after lunch. So the idea is we're going to form some groups. I actually not quite sure how we're going to do it, but I was thinking maybe like groups by 5 people. I don't know, maybe you can kind of like arrange that, maybe 2 turn around and like 2 go with the front or so. Just sort it out somehow. Maybe you guys can assist if needed. But so we're going to do groups of 5 or maybe also 6. And then I would like you to actually use with like whatever tools we've seen so far. You can either use DevTools, Internet should hold up. You can use web page test and like just like plug in like any site that you think is a good candidate to have a look at. So the group should like kind of start any of those tools, have a look at one of the sites of your choice, and just have like a little discussion about what problems you can find, what you think could be optimized, what you think should be optimized. I had a little chat earlier. You don't have to go searching for it, but I had a little chat about like React and Angular and stuff before. I personally don't have so much experience or haven't looked into like many of like React sites, like in terms of like, okay, how do they perform? If you come across one of those, I'm happy to have a look at that later as well. But the idea is then like to, out of all the groups, we're going to pick 3 of them. And I would like to then pull it up here and just like do a 5-minute quick recap and like get some feedback. And one of the groups should have like one person who actually come up and like explain some thoughts. And the cool thing is you can win some really cool stuff. So all of the members of the groups will get a prize, plus like the spokesperson will kind of enter into a raffle for like an even cooler prize. So if I would be, I'd be very, very keen on actually coming up here and doing that, because I think it's a very cool prize. I would be happy about that. So just form some groups, pick a site that you want to analyze, fire up any of the tools we've discussed so far, and have a look, and then in like 10 minutes, I think, 10 minutes seems to be good, or even like if you need a bit more, you can do a few more minutes more, and then we'll discuss each of the ones, like 3 of them for like 5 minutes each or so, okay? And if any questions in the meantime, feel free to let me know. I'm right here or there, and maybe I'll also walk around the world. Cool? All good? Yeah. Very excited, everyone. Come on, breaking up. Go. Yeah, works. Oh, it's going to work. But I think it's okay because like now like kind of
Hindi, kasi naisip ko, ano yung
And we found that it's really nice. We found some low-hanging fruits that we could check out. So we're using the performance budget. We checked out the page weight, network request, and page load. So we found out that the site is actually good with network request, only 11. And however, page weight is around 4 MB. And the page load is 11 seconds. And it turns out that using the webpagetest.org, you were able to check that in the waterfall view, you can actually see the outlier and probably the main reason of all of this. If you notice in the web page earlier, there's this, you see a video or rather the GF file, which actually the one that is being shown here in the waterfall. So when we checked that out, that only gave us the clue, and that's the reason why we need to do the performance test. So both, we found out that the file size is 4.3 MB. So it's basically the reason for everything. And the content download is at 10,000 milliseconds or 10 seconds. So we already knew that this is the key to fix this. So what we did is we actually used an online GIF optimizer, and you would notice that for from MB is now like 600 kilobytes. And I think you can see it here. There we go. So it's almost the same when we use those things that we showed earlier. Okay?
Alright, that's very cool. I mean, that's an easy solution because everything else is actually pretty fast. So the GIF file is like definitely the culprit. And I mean, I'm sure you can like do a lot of other things. It would be interesting to see it like with the new file, and then you probably can see like where else you can optimize it. But yeah, that is still like, I mean, yeah, maybe you can like squeeze a little bit there, but everything else looks actually fairly fast. Okay, cool. Alright, thank you very much. Alright, next team. Who wants to come up? Remember pool price as pool price. Alright, yeah. I'm looking forward to that one.
Oh yeah.
ba to? Ano pang tawagin mo? Demon, sila sa kabilang.
Alright, this one I'm actually looking forward to because it's actually they tested formfunctionclass.com. Yeah. It's a shame Asa is not here. You would have loved that. Okay, I'll give that to you and tell me what you found.
So hi guys. So we look at formfunctionclass.com. It's quite interesting. So top right, the grades. So first flight timing is not very good. Compares people life is great. Cash is terrible. It's at F. If you look at the waterfall view, you can see
Okay, so I think the first paint time 3.5 seconds can be improved at this point because when let's say in the timeline, which oops, I have to turn this off first. Yeah, I have to capture it again, but so if we record it, it would sort of it's loaded down. So you would see here that this one is the one. This JavaScript file is the one blocking the render, and this is the first paint time. So that would be the reason why it would show up like that. Why it's blocking the render.
And the thing is like with those TypeScript and Google fonts, basically those are the only JavaScripts that you actually have to load in the head. Otherwise you get like the Fleischer-Van style content, whereas like it would load like your fallback font and then later it would just like kind of change to the Typekit or Google font. So this is like an exception where you actually would put it in the head as opposed to kind of like put it in the footer, because otherwise, I mean, it's always like a bit of a drawback. And that obviously does render block a little bit, but usually it's okay. But I think with like 3.5 seconds you can actually optimize quite a bit. I'm sure there's like a lot of other things. Also what I noticed, this one, it seems like that the DNS connection is very, very slow because you have like a very long bar. So that can be like either network or it can be like the server or something. For these things it's usually like smart to put stuff on a CDN. Helps a lot. Alright, cool. Thank you very much. Alright, one last group. Who wants to come up? Okay, you guys?
Okay, so we did a performance review of Rappler.com. Okay, so here are the numbers. Our first impact was pretty good. About half a second, but we found that start rendering was a bit slow. Okay, so okay, so we found out that there were a lot of blocking requests when the page loads. Okay, so we found out why, what's causing this. So I found out that that Rappler was loading a lot of scripts in the head that would otherwise be better off loaded the bottom of the page, like jQuery, date formats. We really don't need that at once. And moreover, they weren't bundling their scripts. Okay, so that's kind of a big issue. Okay. Okay, so as for low-hanging fruits for optimization, I think Rappler could have benefited from bundling and lazy loading. I mean, if they used Webpack, I mean, this would be faster. I mean, Webpack has lazy loading for scripts, right? Okay. What else? We also found out that there were performance issues when the user is actually loading the page. For example, the idea is for each render to last around 16 milliseconds since we target 60 FPS. We found out that there were portions of the script that were executing for more than that, such as this one. Okay, so we investigated. We found out that they were doing some funky JavaScript with their scroll handlers. Okay, every time you scroll, it registers and deregisters the timer. So what it does is that it fires off a Google Analytics event, and that's really setting off their scroll times. Okay, so to optimize this, I guess they should have throttled the scroll handlers because it was firing way too much that it's affecting the scroll times. Okay, there.
Cool. I think this is a very good example of those where you don't combine or concatenate your JavaScript files, then you have so many of those, and I mean you can really just all put them in one file because I mean apparently they need them or want them, and you can just concatenate and minify them, and then they will be off much better. I think this is a good example where it's I mean I don't know, I didn't count right now, but it was quite a few. So one of these actually does make a big difference. All right, cool. That was fun, huh? So I can already see there was some excitement, and actually there's a lot of takeaways already. So if you actually practice that and kind of do that all the time, at some point you get really used to it, you can fairly quickly see okay, this is where the bottleneck is or so. I wouldn't say you need to dig in too much into the timeline stuff for now. The waterfall chart actually gets you pretty far, and then if you combine that with web page test, you get all the metrics you actually need to optimize quite a bit. So I would recommend playing around with those, looking at different sites, and just getting a better feel for okay, what's happening, what's the patterns, and you start to see that very quickly if you which resources don't perform so well. So that's quite cool. So of all the groups that have been up here, all the people that have been up here, you can actually all come back and pick one of these little notes, folded notes, and one of you will be very lucky, I suppose. So how many are these? Did you count? No, 16? Okay, cool. So yeah, you can do that now or in a little bit, and just pick one, only one, and one of you will be a very lucky winner of something cool. Just don't forget to come up. All right. Now that we got the basics down and we know how to plan and analyze and use the tools to actually do that, we kind of know what's important to look for. Now we're taking it a bit further and going a bit more towards extreme performance. that means now that we know, okay, we can easily get to, I don't know, 2, 3, 4 second load times and maybe like 2 second first paint. That's quite okay already. But now we want to take that a little bit further, and that needs like some further understanding of a few things that I mentioned before, a few things that will be new. But I'll walk you through that, and then we'll see how we go. So before we talk about that other stuff, we need to talk a little bit about rendering. I mentioned some of those things already. 60 frames per second, we've heard that by now. Rendering performance, layout, and paint. So these are all like important components, and it's actually partially what you see in the timeline. In the timeline, you saw like the green and yellow. So green is like the 60 fps with the kind of like wave, and then there were like green parts and yellow parts. The green is usually the paint times, and yellow is layout. So to explain that a bit more, I will do that in a little bit. So this all goes into optimizing the critical rendering path. And that's what we just talked about, like these are critical resources or like blocking resources. And to understand that a bit better, rendering pages. So, oh, where is it? I mean, you didn't miss anything so far. Okay, so optimizing the critical rendering path, and to do that we need to understand like how rendering pages work, how browsers actually do all this stuff, and there's like a lot of stuff going on in the background. So rendering pages is usually, it consists of like render tree construction, layout, and paint, and I mentioned that before. So basically first, like after you send a request, the browser is waiting for the document object model and the CSS object model to like kind of build the render tree. And then the render tree contains like all the nodes that like basically make up the page and that has to be rendered. Layout is called when the browser computes position of like this different elements, and paint is actually when the browser like starts putting like pixels into like the calculated layout elements. So that's like kind of when actually color or like pixels happen. So that's like all that like the browser, I mean there's like much more that actually happens in the background. There's an awesome article, or like, well basically the spec on W3C, so if you're interested in that, it's actually quite amazing to see what happens in the background, like until you see a web page. If you're interested in the geeky stuff, check that out, it's very cool. Okay, so as I mentioned before, we have like render blocking resources, and there's like different kinds of render blocking resources, and one of them is CSS. So technically you have like the DOM or like the render tree complete, and then the browser will wait for every CSS file that you load in the head of the page, because before you can actually see something that like kind of makes sense, the CSS needs to be loaded. Otherwise you would get like what you see when you basically load a site without the CSS, and you would first see that, and then boom, the layout would come on top of it. So to avoid that actually flash of unstyled content, how it's called, the browser actually waits for the CSS files to be loaded and then rendered. The same actually happens with JavaScript, is also a render blocking resource, and the reason for that is because like JavaScript can actually query the document object model, and to be able to do that we need to wait also for that to be complete. And the JavaScript has to be executed before actually the page can continue rendering. So the more JavaScript, and that's like what we talked about earlier, the more JavaScript you put in the head of your document, the longer the browser has to wait until it can actually continue rendering the rest of the page. And that's why I said earlier, you can put the JavaScript that you don't need, and usually it's fine enough like to put it at the bottom of the page, because then the browser goes like, okay, I have my index HTML, I get my CSS, and then it goes like render the rest of the page until then it hits the JavaScript and loads that. But at least then, by then you can actually see something on the screen. So for loading JavaScript, for example, you have like also different options to how to do that, and there's like basically like 3 ways of doing that. And the first one is like just the default way. You plunk your JavaScript into your page and it gets like loaded wherever you put it. The second one is like defer and the async attribute that you can actually add to your script tags and then load your JavaScript that way. So to explain that a little bit quickly is async basically means like the JavaScript gets like loaded asynchronously, so it doesn't really like render block in that case, and just like tries to like load the JavaScript files like asynchronously. And if you use the defer attribute, you can indicate to the browser that the script is meant or it's not needed so quickly, and it can be like executed after everything else is basically done. So kind of like the same as putting at the end of the document, where you just put it can put it anywhere basically, but it just like gets executed later. So I've tried a lot of loading things with these two, like async and defer. And that's like what I said earlier in the beginning, where like sometimes things don't make sense, because I've actually had it with like async in the head and async at the bottom, and somehow usually you wouldn't need to put your JavaScript at the bottom of the document with the async tag, and somehow it was still faster. So it's kind of like one of those things where, okay, it really doesn't make sense and it shouldn't be that way, but like then if you look at the hard numbers, it actually made a difference and it was faster. So I honestly have no idea why that was, but these things can happen, and somehow I just roll with it and I'm like, okay, I'm not going like hunting for explanations forever, because like, okay, well, if it's faster then I just used it that way. But that's like where I said like, okay, try it out, and it depends on like a per project basis and like what you feel like works well. And the project I tried it on, it was also like a fairly small file, so maybe that's not like representable for like everything else. So it's always about like trying it out. So the next thing, we also mentioned that, is basically the requests. We want to not have many requests, because every request basically takes like somewhat up from like 100 milliseconds to like 200 or sometimes even more. And if you add that up, let's say you have like 10 JavaScript files, you already end up with like 2 seconds, and that's like unnecessary. So that's why you want to combine those JavaScript files into one. Then you only have one request, and it's actually much faster to have a bigger file with one request than to have like 4, 5, 10 files with like that are smaller, but like you have the overhead of the requests. So the same goes for like redirects. Let's say you have a redirect that goes from like, okay, you want to have it like index HTML, and you redirect to either another domain. Airlines love to do that, for example. Airlines love to, like when you log to your air miles or so, they send you from the main site to a partner site, to the other airline site, to the whatever, Asia Miles, for example. They go from like Cathay to Dragonair to Asia Miles, back to Cathay, back to Asia Miles, and then finally you get it. So that's like 5 redirects, and if you add that up, is also like half a second, or sometimes it can be even more. So keep low on the redirects if you need it at all, and then that should be good. Path. The critical rendering path basically consists of a critical resource, a critical path length, which basically means like how long does that file take to load, and the critical bytes, which is like, okay, file size, obviously. And those critical resources are all resources that do render block. So what I just explained before like you actually will see something on the page until all those critical files are loaded, and in the case of JavaScript executed, you won't see anything on the page. It's just blank, stare. So, and you will notice that the more you have of those, the probably like the longer is again your everything above the curve for the speed index. We saw that. So you'll see a lot of white space before anything happens, because all that stuff has to be processed, executed, and so on. So in layman's terms, optimizing the critical rendering path is like getting stuff onto the screen fast. That's pretty much all there is to it. It's a very interesting, sometimes very tedious thing to do. It can take a lot of time, but this is like going after those milliseconds that actually get you like towards like 1 second first render, or like even 1 second load time, quite ambitious but doable, and a speed index of like 1,000 or so. So that's like one of the techniques that will get you to that more extreme thing. I can already tell you, doing these optimizations, like that's why I call the other stuff like the low-hanging fruit. The effort for the low-hanging fruit is like very little, and you get a lot of gains. Whereas like if you do or go after these like milliseconds that take you really to like super fast, it's like a lot of work and a lot of like setups and try out stuff to actually get like maybe 100 milliseconds out of it. So it's always like a bit of a, and again, that's like when budget comes into play. You need to have the right clients that are actually willing to pay for that and do understand why you would want to go after these things. So usually that only makes sense really for people who have like high frequency sites, or like where it's like a lot of like e-commerce where there's actually really like money happening on those sites, because that like translates again what we see in the beginning into real like conversion rates or dollars. So to optimize the critical rendering path, basically you want to minimize the number of your critical resources, you want to minimize the number of critical bytes, and you want to minimize the critical path lengths. And as I said before, critical resource is everything that like blocks your rendering of the page. So you can, this is a good slide where you can actually see that. I don't know if you can see that properly, but it should be big enough. So you can actually see the first one, this is your HTML file, and that basically is always render blocking, because it needs to, well, read the DOM, construct the page, and have all the other assets in there, right? So then the second one, you see is that's the font style shit. And you can see if you go up from there, basically where the index HTML stops is like where the CSS file starts to download. And there also, that's like the real CSS file. So you have the fonts and the CSS file that like come after the index page. And then from there on, you see, I think I can't see it from here so well, but I think it should be actually those guys after that, because I don't think there's much JavaScript in there. But that's like kind of maybe is not the best screenshot to have. That's why you can actually change the order of start time, response time, and all that, because then you actually get the proper load order. Now it's a bit like not the perfect way to see that, but I think the concept is clear, or should be clear, and that's what you want to go after. So again, I have like a screenshot from the Manila Times, because I had a look at it, because I thought like maybe that's a bit more closer to well, obviously Manila. Quite interesting, because they're like actually pulling out 365 requests at like 3.7 megabytes, and considering, I mean, I've been here a couple times, and network speed is like so. I don't know how it's at home, how it is in your offices, but like this year is actually okay, but the last 2 years, like mobile speed was closer to like a disaster. Like sometimes like completely no connection, or like super slow. I don't know if you still have that, or if I'm just lucky this time, but it's pretty like full on, like getting a page out there with like almost 4 megabytes in like an emerging market where you don't have like speeds as we do in Hong Kong, because like in Hong Kong I basically run around with my phone with like 40 mbit up and down pretty much all the time on the street. Then it's not such a big deal, but here I always find it's a bit of an issue, so I don't know how they get away with it. And this one mostly comes from like, and that's another problem that I haven't mentioned so far, there's a lot of like sharing widgets, like all those Facebook thingies, and like yeah, send it to whatever, Facebook, Twitter, share something, and there's just like those widgets that have like 10 sharing sites. They all like pull crazy JavaScript after JavaScript, and they all throw it in the head, and it's pretty much full on, and that like really slows you down, and this like also part of the reason why this page has like so many requests. On the other hand, the standard, yeah, it's very similar. It actually levels in at 4.9 megabyte. At like 333 requests, finishes in 1 minute and 40, which kind of like, I almost get impatient if I want to just like take a screenshot and like, okay, come on, done, and just wait, you know. It's not so much fun. I don't know how people here cope with this, but pretty pretty big. So again, requests, you want to make sure you don't have so many requests. This is like a common thing I come across. Usually that's like due to like some WordPress craziness because it like just pops in like so many files. This one had 35 CSS files. So yeah, you can also just put that in one, I think. And weighs in at like 760 kilobytes. I don't know what they're doing. So anyways, it's just examples of like how to not do it. So don't do this. Just concatenate, minify, compress, and you're better off. And then that's another one, and that's JS files. That example is like 31 JS files at 629 kilobytes. It's also pretty full on, I think. Then you see, it's really like not uncommon. I mean, I don't know if you see that, but I see that quite a lot. So another one. Alright, so to actually get rid of that, I mean, basically follow what we talked so far. And I've mentioned the film strips already. Film strips to actually see, okay, what renders when, and you can like see kind of like a nice flow of like how the page loads. The good news is you don't have to go to web page test to do that, because Chrome DevTools is magic. And you can actually do that in Chrome DevTools. So in the latest version, I don't know when it started, maybe Chrome 54 or so, you see up there is like a little camera icon, and if you click on that and then reload the page, you actually also get like a nice film strip of like how your page loads, and then you can actually even click through those and you see, okay, what's actually visible, and you even have like the timing down here. It says like, okay, this is like such and such milliseconds, and you see actually the progress of the page and how it loads. And this is really, really cool. So you have it all on board, and there's like so much more in DevTools. If you go exploring, you'll find so many things. It's really helpful. Another bookmarklet that's kind of fun, but like also kind of like does the same as DevTools is load time breakdown. It's a bit, maybe a bit clearer to see what it actually does. So you can also see, okay, this is like your network part, and this is the server part, and this is all like what happens in the browser on the client. It's quite nice because it's like visually a bit more clear than the waterfall charts. So you can have a look at that as well. Again, back to the critical path optimization. You don't have to do that by hand. There's really, really cool tools out there where you can actually extract your CSS from above the fold. So, and then you want to avoid the render blocking, so you extract the CSS from like everything that's like rendered above the fold, and extract that, and you could put that like either in an extra style sheet and load that, or you can also like inline it in the header of your document, and then load every other CSS after that. That like is the thing that like, gets your site super, super fast. And there's like grunt tasks that automatically do that for you. So if you're keen on like going after those like milliseconds, this is definitely one way to go. And it's really, it's a bit trivial to get it right, but you can basically extract all the above the fold CSS and it automatically puts it in there. So you would want to do that for landing pages where you know, okay, these are pages like that people hit all the time for the first time, and then after that you can include it in your normal style sheet and just like have it cached, or like, I mean, there's like different things you can do with that. Again, it always like kind of worth trying out what works for you, what doesn't. Is it really necessary? I've tried it twice. Usually I try to not do it because it's never really necessary if you have a small CSS file, but for larger sites I think it does make a lot of sense. Again, it's a bit like depends on your project. Okay, any questions to that so far? Good. Alright, then we're moving on. So everything we've talked about so far basically refers to HTTP 1.1 or whichever version. That's like the protocol that like most of the web is currently delivered with. Now there's like a new protocol that's like coming in as a fairly good game changer, I would say, and it's going to change some of the things we used to know and like some of the things we just learned. So with HTTP2, you can actually unlearn some of those things again. Which is great. It's totally compatible and so on, but like some things just change. And mainly for the better, I think. So I'm going to talk a bit about best practices for HTTP 1 and then 2. Before actually going into that, I'm going to give you a little quick, I'm just going to rush through that because it's like just a bit of a side information, but in history of the HTTP protocol and like what happened and what like changes now. So you have like a bit of a better understanding what happens now with the new protocol. So the first HTTP protocol launched with like version 0.9 in 1991, and that was like a very simple protocol, basically like request, response, and not much more. I'm not going to go into details because I think it's really not so crucial for what we're talking about now, but that was like in 1991. In 1996, finally HTTP 1 was released, and that was like a bit more advanced than actually the first version. There were like some simple headers that got sent with it, like response codes and so on. And then HTTP 1 appeared in 1999, and that was quite a change because they tried to like reduce the load on the server. So they tried to actually limit the TCP connections that you could open or the browser could open to the server, and they tried to like kind of limit it to 2. So now it's mostly like every browser kind of like accepts around 6, and that was used partially, I don't know, maybe you've seen that, like something called domain sharding, where you would get your main documents from your main domain, and then you would pull your images from images.domain name, like you would just get them from like a subdomain, and that would allow you to actually go over that limit of 6 connections, because it's basically 6 connections per host. So you could open 6 connections at the same time to your main domain and to your subdomain, and that like kind of speeds up things a little bit. That was like one of the practices that was like quite common in speeding this up. So the other interesting thing is that like more bandwidth doesn't actually make a big of a difference in terms of like how fast you receive your site. You see there, like an increase from 5 Mbit to 10 Mbit results in a disappointing 5% improvement in page load time. And that's really interesting because like usually you would think, oh wow, faster connection like must be awesome, must be super fast. Is not. The reason for that is round trip time. That's something also called latency. So you have bandwidth and then you have round trip time latency. So we look at this graph, and this is actually quite interesting because like with the 1 Mbit connection, you have like a page load time, I think it's close to 3,100 or so, which is like 3 seconds. And then you see, you pull up the bandwidth like to 10 Mbit, and you merely get down to like, I don't know, 1,500 or so. So it's actually not that much faster, even though bandwidth is like 10 times as fast. So you have round trip time, and basically round trip time, or latency, is the time a request takes to go to the server and then get a response back. So it's actually very easy. I mean, it's like a very simple illustration. If I walk to this table, and then I walk back here, it's going to be much faster than if I walk all the way to the back, get some food there, I could get it on your table, and then walk back here. So it's going to take me much more time, and this is exactly what happens with the request and response. So again, we talked about CDN earlier, like Content Delivery Network. That's kind of like what falls into that category, because like if you have a server that's like in Manila, usually the round trip time is like very short. If you host in the US, then your request has to go all the way to the US and then come back. So with the CDN is usually quite smart because they're trying to pick the closest server to you to actually deliver your assets. So that makes a lot of sense, and this is like where you can get like a lot of gains as well. I do understand not everybody runs everything on a CDN, even I don't, even though I would love to. But again, it's like a matter of budget, it's like a matter of effort, and so on. One good thing is like Cloudflare, they kind of like do that for you. It's very simple to set up. I'll have that later again. So you can do it, but yeah. But anyways, latency, round trip times has a huge impact on page load. And this is interesting. We look at this graph. And you see, we have 240 milliseconds with the latency, and then we're like 4 seconds, and then you decrease the latency, and it just gets like so much faster than the other example. So you can see it actually continually goes down. So you want to try to keep that low, and then again, like CDN is probably, or faster servers, closer servers, and so on. Good quote from that is like, HTTP2 produces the biggest performance gain on mobile because it remedies high latency, and this is like, especially on mobile, because the difference between mobile and normal networks is that you have like a cell tower, and the cell tower usually also like it takes time to connect to that. Plus there's like different other things, like the phone needs to, like if it's been in standby for too long, it actually needs to power up, set up the connection and so on. Does it do a handshake with the cell tower? So in between the server and your phone there's always a cell tower, and it takes like extra time. So you want to make sure the latency is like decreased, and that's like going to improve things also. To make that a bit clearer, latency is the time between making a request and beginning to see a result. And again, there we go into the psychology again. It's kind of like you don't know if that actually was a successful request, or if you're like it has been accepted and so on. So this is also a factor that goes in there. Let's just assume it always works. Technology never fails, but you kind of get the idea on that. So again, with less latency, much faster page loads. So keep in mind CDN and of course HTTP2, where we're moving towards. So after HTTP 1.1, there was like something called Speedy, a protocol developed by Google, which basically set on the existing protocols, but they tried to kind of like make it a little better. One thing they did was like they allowed multiplexing, which basically means you're not limited to like those 6 connections, but also allow concurrent requests in one connection. So like basically you open one connection to the server, and you can get as many or like more than 6 assets downloaded. So this was like one of the big ones. Then they also allowed browsers to prioritize assets, which basically means you can specify which files to download first. This is never really tried it out, but you can say like, okay, if you download the index HTML, you will also for sure need the whatever default CSS. So you can say, okay, load this as the second one. Then there's like compressed HTTP headers, which also takes away a little bit of the load of the actual request. And then there's like something called server push, which is also very cool, because that means you can actually say, okay, my default CSS, I will for sure need that, and don't request it, and it basically gets pushed to your browser. You don't have to actually send a separate request for that file, but the browser already knows, okay, I need that file anyway, so just give it to me. And if you ever see that, like that's displayed as like a gray bar in Chrome DevTools in the timeline. I don't think I have an example of that, but you will notice. It's not so common yet, but that's a very cool feature. You just need to have access to it, or there's other ways on how to implement it, but I also haven't really gotten around to try that out like on the whole scope. Alright, so that was like the Speedy protocol, and based on that there was like the next official candidate, and that's HTTP2, which basically was like last year, and now it's like kind of rolling out, and you can already see that out there in the wild. Quite a few of the big ones are already using that, and also Cloudflare offers it, so if you're keen on that, you can also try that out. So basically, networking protocol for low latency transport, what we just talked about. You can like just get more assets at once, you don't have to wait for those, and it started out from the Speedy protocol. Also multiplexing, compressed header, the prioritization and dependencies is like if you need that, or if you download that index file, you also will need for sure the default CSS and the default JS or something. Like you can specify which files are actually dependencies and like get those right away. And server push, as I just explained. Switching protocols, no problem. Everything is like backwards compatible, so that's cool, and is awesome. If you have a chance, use it. Now, how do we build for that? Because like a few things change, and I mentioned before, like some of the stuff we just talked about today, you can forget about it and have to learn something new. Sorry about that. So, what do we need first of all to enable HTTP 2? So, if you want to run that, how do you do that? So, the first thing you need is an SSL certificate. Without it, you can't run it. That's also fairly easy to get nowadays, like Let's Encrypt. I don't know who's heard of that yet, but I think it's quite well known. It's fairly easy to set up. Some providers even offer like one-click installer, and that is very, very cool. If not, check it out. And even if you don't plan on running HTTP2, get a cert, because that's like the new thing to do. Plus, it's like, I mean, it makes a lot of sense, but I'm not going to go into that, except for like a few additional benefits why you should do that. So one of those is also Google takes that into the rankings. So same as SiteSpeed, like secure certificates also affect your site ranking. And they're now even going as far as like going, okay, every site that is not labeled or doesn't have a SSL certificate is going to be labeled not secure. So if you don't want to fall into that, get an SSL certificate. Let's Encrypt is totally free, and it's fairly easy to set up, so just do that. And then also furthermore, like some HTML5 APIs will also require that very soon, or maybe they do already, I'm not quite sure, but like one of them is like geolocation. So if you're using that, you will also need an SSL certificate very soon to be able to use those. Not sure about China and like what Baidu does, but usually they follow that trend, so I can imagine like seeing that like also happening in China. So then you want to be serving via HTTP2. What do you have to do? So either you're Apache geek and you do it yourself and set that all up, which probably most people aren't. So you're probably running like some virtual hosting, shared hosting, whatever. Then probably your best bet is Cloudflare. So Cloudflare is like the CDN service I was talking about. It's very easy to set up. You just like enter like the DNS records, and they route everything through their service. And then you actually get like the CDN support, and you can actually also put like in a certificate. So very cool, very easy. Free plans also. I run that on my site, for example, and a few others. Works well, so you can go for that. Browser support, getting there, as with everything. HTTP2 browser support. This should be actually, this is from like March. I don't know if it's like, but shouldn't have changed much. Maybe Chrome goes like further up, but anyways. You can use it because like there's the fallback on HTTP1, so there's like no issues there. You can just use that. And again, what I mentioned before, some of the stuff we've learned become the new anti-patterns, and you have to actually think differently about these things and optimize differently if you want to do HTTP2. So, perfect. This is a good time for a quick break because before I go into that. So, how long is the break? 10 minutes or something? 15. Okay. Quick 15-minute break. Get a drink, and then we'll be back with like some more HTTP2 action. Oh, and don't forget your raffle tickets for those people who are here. Now is a good time. Come up, pick one. If you have been here before presenting, come. We're moving, or hopefully all moving to HTTP2. So there's a few changes, and it's going to be really interesting. And as I said before, some of the things we learned today, we kind of have to unlearn them if you want to use HTTP2, because otherwise they're not as great anymore because of multiplexing and so on. So let's have a look at what has changed and what you have to do differently. So the first thing is concatenation of files. So that's what I mentioned, like you shouldn't have like 76 CSS files, you might as well all put them into one to save on the requests. So this is basically, the concatenation kind of like works as a workaround to the lack of parallelism in HTTP1. So, because we said like requests cost time, so we try to limit the requests. The good news is, in HTTP2, requests are cheap. And that basically means you can have as many as you want because it really doesn't matter anymore. So what you want to do instead is like you structure your code so you only actually deliver what you really need. And you can actually avoid like all those build processes because like you don't need to concatenate the files. You can just like leave it as is. You can have like 10 CSS files if you want. And the only thing you want to do is like optimize your caching policies because like you want to make sure like changes are actually getting caught. So requests are cheap, meaning we can have like lots of files, and this is a good example. Unfortunately, you can't see that from back there, but basically this is 92 JS files, and that is from Facebook. And as we all know, Facebook is pretty fast. And these are all, you can see that actually here in this column. Maybe that's also good information to have. Like if you right click on this column, like where it says like name, status, protocol, and so on, you can turn on and off like different features. So you can, for example, get the protocol in there, or you get like the file type or size. I don't know what else is in there. There's like so many things in there. You can just like adjust whatever is important to you as a metric and like look at those. So we see HBook has 92 JS files. They're all fairly small, most of them. Some big ones, there's like one with like 40K, 18, 28, 62, but then there's also a lot with like 7, 6, 4, and so on. They're loading everything on with HTTP2. So everything gets served with the new protocol, and that's why requests don't matter, because you will see that in a little bit, they just like all go in parallel. So you're not limited to those max of 6 files parallel anymore. You can have like 20 and they just go, and that's a pretty cool thing to have. So again, this one, example from what we have had before, 35 style sheets, is with HTTP1, you don't want to do that because it's going to cost a lot of time. With HTTP2, it's like, okay, full go, that's cool, that's fun. You know, you can like basically also load different CSS files for different pages and say like, okay, for my homepage, I have, I don't know, maybe a style sheet that is called home and just has like teaser box modules in there or so. And you don't need to load that on subsequent pages if that module doesn't show up. So you can really like modularize your files and your modules, and you really only load what you really need. It's a bit more effort in like how you structure your files and your code, but it's really cool and really efficient because you only load what you need. Whereas like before we would be like, okay, just give me the whole CSS file, like everything, but make sure it's just one request. The idea is like with HTTP2, you can actually be very selective about like what you want for certain pages, and then you can be like, okay, feeding that on a modular basis. So this is very helpful and very cool. So we'll have a look at a waterfall from one of the previous things I showed. So here you see this is like the HTTP1 waterfall look, and you see like they all come like one after the other, or at least like it's kind of not more than 6 at the same time. And this one is actually a waterfall from an HTTP2 site, and you see, boom, it just goes straight down, which means you have like the render blocking index HTML at the top, and then it just goes full on, and everything just comes as like bandwidth allowed. And that's really cool, and it makes a big difference. So you can actually try that out. I mean, Facebook is a good place to have a look because they're doing it like in a really cool way, and they have lots of files, and it's still very fast. I'm not quite sure. I haven't looked into it into too much detail because I was like, wow, that's a lot of files, but it's still fairly fast, and I'm sure these guys know what they're doing. So definitely worth having a look into that. Then we talked about image sprites before. So image sprites. We don't need that anymore because with HTTP2, as I just said, you can just load as much stuff as you want. So you can save all the hassle of spriting. You can just have like, I don't know, 20 or 100 images because they're tiny. They just come like bam, all at once. So it's very cool. Again, I also have a disclaimer in here, whereas like there might be cases where it's better. So in general, I wouldn't bother about it with HTTP2. Just go for it, but if you think, oh, it's not quite optimal, you could try sprites. maybe it makes a difference. I think it very much depends on the project, but I personally wouldn't go ahead and like waste much time on it because it's probably not going to be better. It really depends. There's also not so much research on the whole like HTTP2 out there in the wild. So I think while this like is being rolled out and more sites use it, we will have like more data on, okay, this works well, this doesn't work well, and maybe you should do this or that. It's fairly new. As I said, it only started last year. Some sites already support it, so it's kind of like worth keeping an eye on it and like see how this like kind of affects the performance optimization strategies. Another thing, inline images. Again, that was like more referring to like the base64 stuff. You can also base64 them like right into the HTML file, or you base64 them in the CSS file. You don't need to do that anymore. And also, if you do that, you can't prioritize images anymore, which is also one of the features of HTTP2. So you might also not want to do that. Then there's like two other very cool things. It's called prefetch and preconnect. So basically, it's a link in the head of the document, and you can just say, okay, like DNS prefetch, which basically makes the DNS request, or sends the request, gets like a DNS response in the background before it actually needs the file. So the handshake, like the DNS handshake, what we saw earlier, like the first bar that was like displayed in the waterfall chart, that basically happens actually before you need that file. So once that file is needed, it just goes like on right away. And the pre-connect, I'm not quite sure if I'm mixing it up, but there's like pre-connect and there was also like a preload. I actually think it's the preload that is doing, or like can do like the server push, where you go like, okay, preload this file, and then it like is pushed by the server. Pre-connect just basically like establishes a connection before that, and then you don't have to connect anymore before you get that file. So these are also things like quite interesting and can make a big difference. I also mentioned domain sharding earlier. So if you actually listen to what I said back then with the 6 connections of the subdomain, since now we can open multiple, or like request multiple assets over one connection, we don't need domain sharding anymore. And even like with HTTP2, it might even have a negative effect. So don't do this anymore if you want to be on the same site. Maybe with like 2 domains it could be okay, but generally you don't need that anymore because there's no reason to do that anymore. So to give you like a good overview of what changed and like what you should do and what you should not do, there's like a nice table. So basically, like the first things, reduce DNS lookouts, reuse TCP connection, CDN, minimize redirects, basically keep file size small, compress assets, cache resources, and eliminate unnecessary resources, which is kind of like a no-brainer. This is like all the same for HTTP2. And then it gets interesting, because domain sharding, you shouldn't do that, and even for HTTP1, don't do it with like too many domains or subdomains, because it's not going to work, it's not going to be good. But maybe you want to do it with like 2. Let's say you have like images.top-level domain and your main top-level domain where you get like your index HTML from. That's okay, but don't do it with like more domains than 2. And then in HTTP2, just don't do it. Concatenate resources, we discussed that like before, so yes, that's good. Also kind of like worth trying out if it's better to have like one super large file or like 2 medium large files. I mean, that's again up to you, depends on the project. And for HTTP2, just don't do that. And inlining resources, also the same, you don't need to do that, and you want to watch for server push because with inlining resources it doesn't work. So fairly straightforward. We had that already. So you need to basically make the move to TLS and a secure connection. So this can be done with like the Let's Encrypt certificate. And then you also want to make sure your server and your browser support HTTP2. So in terms of like browser support, if you see in your analytics that like most of your visitors like are on a browser that doesn't support HTTP2, you might want to like not do it right away and like consider, okay, that maybe like a future upgrade, or like consider doing that in the future, because otherwise it doesn't really make sense, even though it's like backwards compatible. And especially with like preparing all your assets, like the difference between serving one CSIS file or 20. If you have, I don't know, the majority of your users being on, I don't know, let's be evil and let's say like IE6 or so, then there's no point in actually doing that, because then you do more harm than any good. So check your analytics and see like what's your major users browser support. If it is like latest browsers, totally go for it. If it's not, you might want to wait and see when they're gonna upgrade their browsers. Yeah, also again, I can stress like the CDN enough, because that's like reducing your round trip time, and that makes a big difference. And you should definitely look into like something like Cloudflare if you don't want to like go full on, but like also Akamai or the big ones if you have clients that like run massive sites. Maybe they're already on a CDN, then it's great to actually make use of that. Alright, again, preparing your assets, you can like also create build tasks that do all that for you. So it's fairly straightforward to have like a grunt task or a gulp task that whatever one is called HTTP1, and it just like throws out like the combined ones, and then you have another one set up so it like creates HTTP2 assets where you have many files. It's fairly easy to set up. You can set that up, and like by the time you have the browser support to actually make that switch, you just actually have to run that once and deploy, and you're good. So it's a bit of like a forward thinking in that case, and it's alright if you have it prepared already. Again, I mentioned that already, analytics and browser support. You can choose what you want to implement. I mean, there's like many things we talked about. Again, depends on your project, what you want to do, and caching policies are also quite important. And the interesting thing is, and that would be awesome, if you do that, measure performance before you do it, and measure it after, and actually let me know. Because like there's like not so many use cases out there where like people will go like, okay, before it was like, I don't know, 4 seconds, and after I've upgraded to HTTP2 it was like suddenly like 1.5. I haven't heard many of those stories yet because it's not so widespread, and basically not so many people have actually done it, and the ones who've done it, I haven't seen any case studies on like, okay, this was the gain, or like this was like how we improved performance on that. So that would be really interesting, and like just put it out there, write a blog post or share it on Twitter or wherever, so actually people can find that, because it's always like very, very highly sought after, especially like for people who like work a lot with performance. Like we want to know these things. Like that's so cool if people share their stuff. As I said, like that Facebook article or the BBC one, it's very cool to read these things, and it's like always you get good ideas. It kind of like motivates you or inspires you to actually also try that out. So make sure you share that, and even if you think it's not worth sharing, that's usually not a very good thought, because there will always be someone who will be very, very thankful for like someone sharing stuff where you can get like some information or even motivation. I find that is very, very important. Okay, so that's pretty much it so far. I'm gonna run through like a few more tools and resources, and I think then we do have plenty of time. No? We have plenty of time. Cool, we can do some cool stuff. So we still have a lot of time, but let me run first through the tools and resources, and then maybe we can do, I don't know, I would maybe leave it up to you. We could do like another exercise if you want, and have like some other people like come present, or we look at some other things, or we can do like extended Q&A. I would leave that up to you. I think maybe the Q&A is quite good, because there have been like some really, really good questions. And if you want to do that, or if you want to know something else that hasn't been covered, we can also discuss that. But let me run through those things first, and then we'll just go from there. Alright? Is it okay now? Alright. So first of all, we talked a lot about like Chrome DevTools. So it's a massive tool, and there's so much stuff to discover and learn about it. I'm really happy to see like by now there is like on the Google developers pages there is like extensive manuals explanation to every single thing that's in Chrome DevTools. So if you really want to dig in deep and like understand every single bit of it and like what it does and how it works and how you can make use of that, go to developers.google.com. There's like tons of stuff there. There's also like other performance stuff. There's like the critical path stuff on there. There's like basic optimization. There's I don't know what else. It's massive and it's really, really cool. So if you're interested in like learning, understanding more about DevTools, this is definitely the place to go. Very, very cool. Then we've seen like some of the groups here used some different tools. So one of them was like Pingdom. I think it's pingdom.com. Is that right?
Yeah.
Yeah. Okay. And you had another one, right? GT Metrics. Okay, I don't know that one. So GT Metrics could also be a good one. Basically does, I think it's very similar to what web page test does. But have a look, or maybe there's like a personal preference, like one that you like more, one that you like less. Also web page test has like a cool API. So if you want to geek out on that, you can also use the API. Also very cool. And then there's one more, which is kind of like a little bit an older one that's been around forever. It's like Yahoo's Wislow. That's available as like extension, and I think they even have like an online version or so of it. Haven't used it in quite a while. It gives you like kind of pie charts about like assets and all that, and file types. Also gives you like a grading. I haven't looked at it in quite a while, so I'm not sure if that grading is kind of like the same as the web page test one, but it basically also gives you from A to F on certain criteria. So that's also worth looking into. I used to use that a lot back in the days, but now not so much anymore. And then if you're into tooling, whatever, Grunt, Gulp, NPM, whatever, there's like some cool sites that have all the things on there. One is perftooling.today. Basically you find more than tools on it. There's like all the tools, there's articles, there's talks, there's books, there is I don't know what. You can get really, really busy with that. There's lots of stuff on there and everything you want to find there. Also the grunt tasks I was talking about and many, many more. Then there's another one which is called perf.rocks. Also lots of stuff on there. Tools, people, talks, articles, more tools. And then a friend of mine also created quite a fun tool which is called Perf School. You can run that in Terminal, and it basically also like guides you through all the optimization steps. Very cool. So you can have a look at that. That's maybe a good one to just like kind of get into if you're not scared of Terminal. I mean, I get it if that's not your favorite app to use, but this is quite cool. Then again, I talked about the critical rendering path optimization. You don't have to do that by hand. There's tools, like one of them is like Run Critical, where you can also run it with Gulp, which basically you specify like a viewport dimension, and then it extracts like the CSS that is required to actually make that visible. And you can specify also if it's going to put it like inline into your document, into the head, or if you want like an external CSS file with it. So very straightforward. And again, the page speed index that we talked about, like because you can specify like the dimensions for the critical path optimization, it basically always like refers to like the viewport size. So your page speed index will or might vary from like the desktop side to the mobile side, because it's less area that it needs to be painted on. So there will be differences. So don't be surprised if you have like on mobile you have like a speed index of 1200, and on desktop you suddenly have one of like, I don't know, 3000 or so. Not so good, but still, like they can be different, and they will very likely differ. Then also what I talked about Grunt on CSS, definitely worth having a look into, especially for those people who work with like Bootstrap, Foundation, It's gonna make you so happy. It's incredible. When I first used it, I was like, wow, this is awesome. And suddenly you kind of like, okay, framework turns into like, wow, you can actually do really cool stuff with it. And that way, if you actually also use like semantic class names with that, then you're good. Nobody can actually complain much about it, because then everything is more or less pretty alright. So definitely recommend that. Then there's like tons of books. I think there's probably many more, and the Google resources are about as comprehensive as all those books. But I think it's nice to actually have a paper book in hand. I don't know if you guys read paper books. I like it. But these are my favorite books. So the first one, Time is Money, is actually a very new one. And that is the one that like talks a lot about the psychology part and what's happening in users' brains. And you actually don't, oh yeah, I should have said it earlier, but I will provide the slides, so you don't have to write down all the titles. I will make the slides available for download, so you can actually read up on it, because type also is small. But anyways, Time is Money, very cool on like what happens in users' brains, and there's like a lot of the stats I showed, like from the surveys, is also in there. The other one from Lara Hogan is like Designing for Performance. That's a very good book, but it's more like, I would say it's more like an overall scope on like, okay, what do you have to do, how do you approach what's important. The High Performance Mobile Web is a very cool book, which I actually technical proofread that, and it's fantastic. It's very much more focused on like the mobile part, whereas like today we went more like broad, but it talks only about mobile. So if you're doing like a lot of mobile apps, sites, web apps, whatever, there's a lot of more tooling tips in there. There's like emulators, testing tools, and especially like going also into WebView. Is it called WebView? Yeah, it's called WebView, I think. Facebook, like in-app browsers and all that, and like tons of stuff. Also very good. And if you really want to geek out, then these two are for you. High Performance Browser Networking. This is like where you get really into the geeky stuff, where you can, okay, you want to get to the milliseconds after what we talked about. This is your book, because it actually, you will understand how networks work, what the browser does and all that, and then you can fully go in on optimizing on that. And High Performance Images is also part of what I scratched on earlier, where there was like that talk. It's basically different web formats, how to hardcore optimize for them and so on. So I think if you've read all of that and then like kind of spend a couple of weeks with the Google pages, then you're at expert status. So very good resources, definitely. Right, I'm very sure like I also forgot a few tools, so if you like find anything else, share it somewhere, share it on Twitter, very happy. If you have any questions, like I said, or any comments, feel free to email or so. I'm very happy to put more stuff in there. But I think it's just like overwhelming if you like have so much stuff to read and like so much stuff to learn. It can be quite overwhelming. Alright, so basically it's about like remembering that like the whole performance optimization stuff is not only about the technology, it's also a bit of a philosophy. You have to really want to do that, and like before you actually want to do that, it's like you have to understand why you want to do it. So acknowledge the fact that this is like an important thing. And again, clients, stakeholders, sometimes it's really difficult to get them to buy in on that. But there's like so much research now where you have like actually hard numbers of like, okay, this is going to be the results, or like this can be the results, or for others those were the results. I've also seen it like a lot of times it requires some like cultural change in terms of like how you approach projects, or like how you think about like what I said earlier, like this design process is very important, like to incorporate that already, like talk with the developers, talk with your designers. There needs to be like a constant conversation around that. And sometimes it's very difficult to actually get people to buy in on that. Especially, I don't know how you guys work, but I still come across a lot of people where designer designs website hands over Photoshop files and then somebody builds it. It's not the perfect way to go about this because you have very, very little say in what's happened before. So you get that Photoshop file, it's very, very difficult for you to come up and be like, oh, you know what, we have problems here and here and here and here, and it's going to be slow. Nobody will be like, okay, cool, I'm just going to change everything, you know? It's like, it's very difficult to actually get that done. So that's why you want to talk to people early on and bring them on to the process. Yeah, so the whole performance optimization is more like of a journey than a destination. And with that, I would like to close now, and we can maybe have like a quick Q&A and see then, like, we still have some time, and then see what else we do with that remaining time. But I think maybe Q&A is quite helpful because there have been like some really good questions, and I would encourage everyone to ask lots of questions after like so much input. Okay? Supports HTTP2, then you will see like in the DevTools that it says like H2, and that basically which request from which or which asset actually comes back via that protocol. Sometimes you see, I don't think I have a screenshot now, but like for example, some pages would also say SPDY 1 point something or so, and then that's like basically HTTP2, but it's not. So the server will like give you back like what they're sending the asset or the resource with. So if it does HTTP2, it says it like in the protocol column, or you also get it like in the header information of that resource. If it doesn't, then it just comes back as like HTTP 1.1 or SPDY, and SPDY is basically kind of like the same thing.
Hi, Holger. Just want to ask if you have any comment about using APM and RUM tools like New Relic. So for our group, we're actually using New Relic a lot, and maybe you can share some of your experience of what you think about it.
I have used it once, I think, but that's a very long time ago, like 2 years or 3 years or so. I can't really comment on that, sorry.
Okay.
But maybe, what's your experience? Maybe you could share something about that. Or
Yeah. Well, for us, we're primarily using it for a Drupal site. And what we have focused there is basically first on system monitoring. It basically monitors the code and the database, which ones are not working. But now I want to hear more about front end.
I think
Because they have
probably,
part for that.
yeah, it probably more applies to like the backend, no? And like New Relic is like, it's at the Rails app, right? Or is that?
Yes, that's correct.
And they're like just looking after server performance, database, and all that, or?
Yes, and they also have what we call RUM.
For someone who doesn't have any experience regarding automation tools, what would you recommend to them?
That's a very good question. That's a very good question, because I find like generally like I'm quite opinionated about the whole tooling, and sometimes I think it's like so much setup to actually get like a little thing done, and then whatever, you upgrade Node and everything breaks, and then you like kind of have to figure out what works. So for beginners, I think this is like a very, very frustrating path to go down. I think for beginners, it's probably a smart idea to kind of like find or like look at whatever modules you have, and I mean every good module comes with like a okay documentation, I would say. Like sometimes it lacks a bit, and sometimes it's also a little bit complicated to find out. Okay, except for example like the on CSS or so, you have to like really dig into it to find all the options available, because like usually it's just like the grunt wrapper of like another tool, and then basically you have to find your way from that grunt wrapper to that original tool, and then look at the options and kind of figure out how do I actually get that in there. But I think a good approach is probably just starting out with the basics of whatever module you have. Take the examples and try to kind of like adapt those examples so they actually work for your project. So you don't have to like kind of know too much about it. Basically, you kind of like make it to install, and then you copy those examples. Maybe that's a good way of like actually implementing it. Because otherwise, I mean, the other way is like, okay, learn JavaScript, then you're fine. I think there's also like a long way to go to make that like kind of publicly consumable, because I think that the whole tooling is like, it's also getting out of hand, and I find like it's growing so fast and there's like a new tool every week. I mean, now everybody's like, oh, Yarn, great, yeah, let's use that, you know? When Grunt was out, everybody thought, oh, Grunt was cool, then like suddenly, oh no, Grunt is bad because now we have Gulp, and it's tiring. So I totally agree, for beginners it must be the most frustrating journey ever. But I think starting out with like code examples, trying to understand what those bits do, and then like kind of stacking them together. Not sure, but yeah, I think that would be the approach I would take.